Oh yeah, we are back in town, guys. We are back in town. How is everyone doing this evening? Hopefully not too sleepy after staying up far too late watching me struggle with this bloody Hertz amplifier last night. So, this evening, the plan is to get to the bottom of all the nonsense that we had yesterday. Wow, what a saga yesterday, hey guys? What a saga yesterday. Now these kind of amplifiers that give me these kind of headaches are actually quite rare nowadays. I've been doing amplifier repair as my day job. Like, I've been, repairing like multiple amplifiers every single day for a whole number of years now. So I kind of got used to getting a rough idea of what kind of faults are present when I see certain kinds of behavior and stuff like that. But that Hertz last night, that was throwing up all kind of curveballs my way in terms of the stuff that it was doing. And but I think we were kind of getting there. We were getting there with it. But I think in order to speed up the process, seeing as I have this here anyway, now this is a godsend to have an amplifier here which is the same but that doesn't exhibit the same fault is a kind of a godsend, because it's the key to the problem with the other one. So if you're ever struggling with an amplifier and it's not a super rare amplifier, if it's like somewhat relatively common-ish, or if you can definitely find them around, I highly recommend, rather than spending hours and hours of your life looking and struggling for answers with something, especially if you don't have a schematic or a service manual, is to just wait until another one comes up that's the same, or maybe even buy another one that works. Sometimes if you buy an amplifier on the used market that works, that's the same as the one you're trying to fix, you can buy it, use the working one to fix your broken one, and then you can sell both of them, and you haven't lost any money there, because all you've done is you just bought a used one you can sell for the same amount of money again. But it got you, it saved you time in fixing the one that you are struggling with. And at the end of the day, your time is worth money. So if you have to spend 200 quid or something on a used amplifier that works, if it gets your broken one fixed and you can sell both of them for 200, or you can sort out your customer's one, then happy days, it saved you some time. So yeah, just by chance I happen to have this one in for repair as well. And this is the same Hertz HP1D as the amplifier that we had yesterday, and I would be very surprised and very pissed off if this has the exact same fault as the other one, because the other one is such a strange fault. Like I said, it's not something that I see very common, so I would be very surprised if it did have the same fault. So let's take a peek inside and see what has been repaired before. because the other one had lots of things repaired before in parts of the circuit that I wouldn't necessarily say usually get repaired, you know. So it was a bit of a surprise to me when I saw parts of, you know, the part chips over here and stuff like that were missing and that have been replaced, that, you know, aren't usually parts that die. So let's take a peek at this then. Here we have the same thing that we were looking at last night. Now this one that has been worked on before. Looks like we've had output section repair. The driver board is at an angle and the headers are around the other way to enable top board access to this driver board here, which is nice. It means you haven't got to, because it's a bit of a pain in the arse, you have to remove the driver board, whereas in this orientation we wouldn't have to remove the driver board to fix the amplifier if it needed fixing. So what we're going to do first is, I think we are going to repair this one, get this one fully up and running, and then look at the board values and stuff like that on this one to try and translate that to fixing the other one. And just taking a quick look at this one though, it does look like this amplifier has had the 074s replaced at some point. Perhaps there's some solder flux along here, along this one, and this one is a different model. It's a different batch, a different make of 074 CM. So that has been replaced at some point in its life. The one I'm interested in is the 74HC959 because that died on the other amplifier as well yesterday, which is very strange. That doesn't really necessarily look like it's been replaced. That doesn't show typical signs. This one definitely has flux around it and it's a different model, so that one's definitely been replaced, which is interesting. So maybe is this a common problem with these then? You know, for both of these amplifiers to have had their 074s replaced, that's a bit strange. So I did a little research yesterday, spoke to a few people that are a bit more knowledgeable about the different types of op amps than I am, and they said that 074CN is quite sensitive to electromagnetic noise and spikes and stuff. They're not massively durable, so I was recommended a couple other models of op amp to throw in there to see if it was any more reliable than the 074s. So just removing all the clamps now from this one. This one, I think that the client said that the amplifier came on and made a loud pop. Maybe it was this one that made the loud pop. I thought it was the other one last night that made the loud pop, but perhaps it's this one. So I imagine we might have output section failure, perhaps. So just remove all these clamps here real quick. Just kind of take all these off so we can read any shorts on the FETs, etc. Hello to all in the live chat. Good evening. Who have we got here? Matt, what's going on, buddy? Head cam time, absolutely. Jack the Ripper. Rian. Midnight Express. Oh my god, something I can count on. Last night at 1:30 AM, I left my truck lights on and killed my battery. Fuck. Not good. You have to bump start it. Okay, so all of those have been removed. Multimeter time. Hello Reese, how's it going, my man? Good to see you here, buddy. Good to see you here. Big ups for pronouncing my name semi-right, I appreciate it. You have trouble saying the soft G. Hien. I think it's maybe like Hien. Yeah, it's like a soft G, so you don't say Gian, or like when I first read this name, I thought maybe it was Giant, because you know if in the UK with a English pronunciation you might pronounce that as Gian or Guyan, but I think it's like Hien, something like that. You're Sussex tonight, mate. Fresh head, new day. Exactly. Fresh head, new day. We're not cracking open the wine this evening either. I need all of my brain cells on full functionality for the nonsense that these amplifiers are giving us. So, yes, absolutely. Just gonna crack open some apple juice. Apple juice is great. I love apple juice. Really tasty shears. Very high in sugars though. natural sugars perhaps, but very high in sugars. No added sugar, but still very high in sugars. Alright, so why is this one in here then? What do we have? Let's take a look on the output section first of all. Flip our probes around. We want the positive on the source. Okay, we have a 320. This is charging, so we're going to settle at a 572. Okay, that is on one bank. Let's check the other bank. We settle on a 530. Excelente. Let's flip around. Other bank. Okay, this side we settle on a 573. And finally, this side we settle on a 519. Okay, so no shorted MOSFETs. Okay, no shorted MOSFETs. Power supply section, we are charging the power supply caps, so no shorted power supply caps. Alright then, very intriguing. Why is this amplifier here? Alright, let's power it up. At this point then, we've checked all the MOSFETs, and now we are safe to put a little bit of power into the board, as we always do. As we always do, guys. Standard procedure right here. You're learning, you should probably know this by now. If you've been here for any considerable amount of time, check all the FETs. If no dead FETs, no dead power supply FETs, no dead output FETs, then in order to diagnose any issues, we need to put some power into the board, and we need to check all the rail voltages, see where they are. Where are our favorite rail voltagey friends? So power supply on, gonna give it 10.6 volts. Let's let 3.4-ish, there we go, 3.4 amps into the board right now. And we're just gonna pulse the remote a tiny little bit. So I'm gonna take my oscilloscope probe, I'm gonna put it on the power supply FET drain, which will give us on the scope screen 12 volts, or in this case 10.5 volts worth of input. We just wanna pulse the remote ever so slightly to get a little bit of rail voltage into the board. So give it a pulse. Bloop, there we go, tiny bit of rail voltage. Now, we're going to move our probe over to the output FETs over here, and we're going to see if we have any rail voltage where we shouldn't have. So, high side, 0 volts, high, 0. This side, low side, low voltage rail, 0 volts, low rail. That's good, that's what we want. Other side, we have high side, 0, high, 0, and low side, low, 0, low. Cool, that all looks good. That all looks good. Weird. So let's power it up then and see if we get output switching. You know what would be lovely if this amplifier works, because then that gives me a full like 3.5 hours or whatever it is till it starts getting late to fully work on this other amplifier and just reference this one for parts and stuff. So now let's give it a full power up. We're going to put our oscilloscope probe on the low side drain, which will give us our switching wave. So yeah, let's give it all she's got and see if this comes on and switches. Turn the voltage up a little bit on the scope screen, go into 2 microseconds, and away she goes. Bing! Alright then, gentlemen, we have yes, output switching. We have 2.2 amps. It's a little higher than the other one, actually. That's a little higher than the other one. In addition to that, if we also take a quick peek at the wave shape here, does that wave shape look a little funky at the top there? Need to check what it looks like at the gate resistor. Oh, here we go. The gate drive does look, whoa, very funky. Wow. Okay, that is a big spike. That is a very, very nasty looking spike on that gate drive. So these MOSFETs actually look like they've been replaced. In here we've got 55 N25. And I'm thinking that perhaps the gate resistor value is too high. This is a classic sign that the gate resistor value is too high. We're not getting like that bump there where it turns the MOSFET on. That is pretty intense. And we want a lower gate resistor value in order to let more charge in. We don't want it resisted so high so far. Let's just check the other side of the board. Let's just make sure it's the same on both sides. We might have to, I don't know, maybe we could just drop in some 260Ns like we have in the other board, because that looked a lot cleaner than this one does. Let's just turn it on and check the other side. Yep, same looking drive there. So, okay, no worries. So, this amplifier does turn on the switch. However, the other one did as well. And the problem with the other one was that we had really janky looking audio. We didn't have any audio, and it was terrible. So the next thing to do is to get our RCA wire and to plug our RCAs in and see if we have audio output on this amplifier. But just before I do that, if you were here last night on the stream, then you will remember that we had some DC on our audio. I want to make sure that we don't have that here. If we have that here, I'm going to lose my shit, because that means both these amps have the same problem, which is a nightmare because it means I don't have a good working one to go from. I was hoping that this one was going to have like dead FETs, like normal kind of repair shit, blown power supply, blown output section that I could just repair, and then the preamp section would be absolutely fine as it would normally be. But I'm starting to worry now. This amplifier seems fine. Please don't be the same as the other one. So we need to probe this point over here, R34M, and we are looking for no DC on this, please. No DC on this, please. We want just 0 volts for now, and then when we put a sine wave in, we want a sine wave to be present on this pin with no DC offset. So please, no DC. Oh my days. Are you freaking kidding me, mate? We have minus 9.6 volts. Now, oh, for fuck's sake. How are these both the same? We're now going to turn on our thermal imaging camera, and we're going to see, are these 074Cs getting very hot? Because they must have DC on them. Okay, so what do we got? No, we don't have any heat really over here, like 23 degrees. But I think that one of these is probably going to have DC on it. Let's have a look over here. So we're going to go for, you can see the scope screen here. So watch the little scope screen bump up and down. Let's just zoom in a little bit on this actually. Zoom in a touch on the old Scopy Ruby. There we go. Oh, that's better. Get my camera sorted out a little bit. It's a little bit sideways. Might just have to deal with that. Alright, so now that we've got our scope there, let's have a look. So we should have VCC plus minus. We've got 12 volts on the negative VCC, and we got plus 12 volts on the positive VCC. That's good. And on this first op amp, we have, do we have any DC on any of these legs? No, we don't. Okay, so there's no DC on any of these legs. That was the minus VCC. Okay, how about the second zero? Okay, so on the second one is where we have our DC. See, they've got minus 9 volts there, minus bloody 4.8 there, etc, etc. So there's some DC, and there's plus 12 volts on this one. Okay, so our DC is coming from this second bottom 074C. Oh my days, why is it the same? Alright. Okay. So, what I really want to do now is I want to drop something other than a 074CN in there. I wonder whether that's just not the right part for this. Right, I do have, I have a board here, a spare donor board that has some spare 074CNs on it. Now, these are good ones, and these are, you know, genuine ones from whoever made this shitty amplifier. So, what that will tell me, if I pull these out, and I drop these into this board here, we can see whether they die. If they don't die, then it must just be that these Hertz amplifiers were fitted with a really bad batch or something of 074Cs. But if they do die, then I am baffled. Like, what? So okay, I would understand if like the other amplifier had a strange fault with it. Okay, like some capacitor leaking somewhere, some resistor leaking somewhere, that was killing those op amps. That would make sense. But for this one to have it as well, that's not like just a random coincidence of like a bad capacitor or something causing those to die. That seems more like an incorrect part, faulty batch, poor like amplifier design is wrong. But there are plenty of these amplifiers. There are plenty of these. you know, there are plenty of these Hertz amplifiers floating around that don't have this issue. You know, they don't have that problem at all. So why is it happening to these? How come you have such awesome Christmas sweaters? Dude, Jay! Merry Christmas from the land of sweets. Get with you later. Buddy, thank you very much, Jay. Massive appreciate that. That's 500 of your sweetest... I think that's is that Norwegian kronas? Is there a difference between the Norwegian and the Danish? Would Danish be DOK? Danish would be DA, DAC. Danish krona. But my man, thank you very much for that. That's freaking appreciated. That's freaking awesome, man. Thank you very much. From the land of sweets. Sweet like Danish. Guys, if you don't know, this man right here is the man you have to thank for the beautiful sweetness that is B2 audio. Thanks, Jay. I appreciate that. Yeah, well, I'll chat to you later. Got some stuff to chat to you about, so hit you up in a little bit, and we'll get some stuff sorted for you. Because I have a few ideas for you as well. So, yeah, I'll shoot you a line after the live stream. You can pick it up in the morning. Okay, so let's remove these. Let's remove these 074Ns. Now, yesterday we were removing them with a hot air gun, but I just realized I don't have to do that anymore because I have my soldering tip has arrived finally from overseas. Took long enough. No bloody stock in the UK, is there? So finally the soldering tip arrived, so now we can remove these much cleaner and sweeter. So I'm just going to remove 2 of these bad boys for now. And then if these die, I'll remove another 2. So I've got 4 spare on this board, and I'm pretty sure I've got loads of spares from loads of other donor boards. These are pretty common parts, and yeah, they're not the best quality of dual op amp either. So not too fussed if they die, and they're very, very replaceable. And I think that if this does keep killing them in the Hertz amplifiers, I think that the solution is to get something else in there. Get something that's much more resilient to kind of, you know, EMF and stuff like that. One thing I do want to check though is I want to see whether on this amplifier the screen works. Remember in the other one, the level shifter chip failed for the screen at the front. So I want to see whether the screen at the front works on this one. And if it does, then we can swap the level shifter out between the amplifiers. Hopefully it doesn't kill it on the other one. And we can see whether the screen actually works on the other one with a working level shifter. Do you just wiggle it out or pull it? A bit of both. So obviously there, the way I was desoldering these ones was I was using my soldering iron and I was flooding solder onto the pads, running it up and down either side, which was kind of melting up and down either side. And then I was just having my tweezers on here, just kind of, I was just kind of putting a little bit of downward pressure, but not pulling. I was just wiggling and a little bit of downward pressure, and it just kind of walks its way out there with the wet solder from either side. Kian, thank you very much. Supporting once again. Just a little one, homie. Merry Christmas. Dude, massive appreciation for that. Thank you very much. That's awesome. Man, you're always there. You're always there for me, man, when I need you most. Cracking up about British accents and horrendous slang that we have over here. Good times, man. Let's run some flux on this one. Now, because I'm going to try what we did last night with the top board repair, because this one seems to have less problems than the other one. Although it started out the same, didn't it? This one is starting out exactly the same as the other one. So, yeah, we're starting out the same. Hopefully we won't end up the same. We're going to keep the heat well away from that level shifter this time. We're just going to use the small hot air station here. Any update on the Proton? I probably won't have massive updates on the Proton for you until the new year. So it's at my good friend's house, who is a legendary mechanic and paint specialist, bodywork repair specialist. He's an absolute boss when it comes to cars. Does anything to a very high standard. He does, he runs a proper garage. He does insurance repair work. He does stuff for Aston Martins and quite luxury cars as well, and old school stuff, old school Beamers, Rolls Royces and stuff. So he's the one that he's actually sorted out the paintwork on the Proton recently, and he's going to now sort out all the mechanics. So I won't have an update yet. I said to him, look guy, there's no rush on this, just take your time with it. And he's also recently just had a baby. He's had a little girl, so I don't want to rush him into things. Just said to him, take your time with it, just give me a shout as and when. Yeah, he should start a YouTube as well. He would actually do very well. He's a lovely guy. He would do very well. Okay, there we go. Both op amps nicely out from there. Now let's get these one. Let's try and get these back in then without actually doing anything else. That would be quite cool, wouldn't it? We can just sort of hot air these in from the top. Hot air is my new best friend. It's so versatile. You can do so much with it. Now I'm going to try and get this tip to last a bit longer than they have been. So I have just been running these tips at 480 degrees Celsius at all times, because it just makes soldering, especially large traces, just makes soldering a lot quicker because there's more energy in the tip. But for small stuff like this, just kind of getting the solder off these legs, just going to turn it down to about 380 degrees Celsius to try and, lengthen the life a little bit of these tips, because they're not particularly well stocked in Europe at the moment, as I unfortunately found out recently. Ian says, thanks fam, getting licked tonight, innit? Yeah, getting licked. Man's getting licked tonight. Where's my tweezers at, bruv? I still cannot believe how these both have the same bloody fault. What is that all about? What is that all about, hey? Can't believe it. There we go, that's one in. Let's grab the other one. The tweezers I'm using tonight aren't quite as long, so I was burning my fingers a little bit there. Where did I put the black tweezers I had earlier? I'm not too sure. The interesting thing will be, okay, if so obviously yes, this amplifier does seem to have exhibit the same problems as the first one, but if I have any tiny stroke of luck, by replacing these two op amps here, we will get audio on the output of the amplifier, which will be fantastic, because then that gives us an amplifier that doesn't have quite as many problems as the other one, and I can then use this one to diagnose the audio pathway That's the thing that we're kind of struggling with on the other one, is the audio pathway. It seems very strange, and it just kind of grounds the audio. It's just so weird. Beverage, do you still use Basebox Pro for your box designs? Yes, I haven't really designed any boxes for many years now though, so like, yeah, I guess if I was going to design a box, I would still use BB6 Pro. But in all honesty, I haven't actually had to kind of think about that or do that for a long time, so not sure really. The best box design program that I've ever come across is Horn Response. That is a beast of a program, and it is definitely lends itself well to quarter wave box designs, which is what I would probably, you know, start sort of leaning towards anyway if I was going to be doing any kind of box designs for any subs or anything like that. Quarter wave stuff is fantastic, so. Okay, now that is in, but obviously because these are seated so close together, it does look like this one's trying to have sex with this one. It's kind of mounting it a little bit there. That's fine for the purposes of what we're doing. That's absolutely fine just to get it in there. Yep, that'll do nicely. Just run a little bit of solder on any of these that look like they're missing solder from the holes. Just kind of add a bit of fresh stuff to these. The dimensions on these ones must just be a tiny bit bigger than the ones that were in there originally. Which also makes me wonder, were these actually originally 074 CNs, or were they something else? Alright. Wait for that to cool down a bit. Maybe last night, actually, I don't know, maybe I was turning them on while they were still too hot from soldering, but I don't think I was. I think the thermal imaging camera showed us that they were quite chilly. But Ian, that is a good question, you know. Where are my tweezers at, bruv? The black ones that I started using this stream. Here's my silver ones. Alright, I'm not sure my black ones are gone. That's right, we'll have to make do with the silver ones for now. I had them in my hand at the start of the stream. I was like doing this with them. I was like, la 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 la. This amplifier reminds me of the 10K amplifier that gave you some real fight, and it turned out to be tiny resistors on the driver board. Oh, that was a great one. Yeah, that was pretty awesome. That was a really good troubleshooting one as well. Glyn Watkins, hey sexy man, always good to see you. Good to see you too, my man. Very good to see you too. Thanks for joining the stream. I got the same amp in pieces, says Rolling Coal Rolling. Well, hopefully it's not got the same problem this has. If it has, then it shows that it's potentially a design flaw. All right, so I think these have cooled down enough. So we're going to turn it on now and just double check, see if we've got any DC there. Shouldn't have any DC. So we're looking for DC on R34M. Okay, so let's go. Power supply on. Remote cable should be in as well. That's fallen out. I should probably just screw this in, shouldn't I? Just fucking falling out all day long. Okay, there we go. We have no DC on there, which is good. Okay, so the DC has disappeared, we have 2.2 amps of current draw, which is a little bit higher, but I think that's because of the output fetch being a little bit harder to drive than the other amplifier. So DC has disappeared. So now then, the big question is, do we or do we not have tattooed on your bottom the words, Jesus is coming, look busy? No, that's from a film. Do we or not? Do we have or do we not have audio output from this amplifier? So let's make sure that it is on master mode, not slave. Let's just take a quick peek at the, at the settings here. At the settings, how high is the gain? Gain is, level is, that's pretty low actually, it's down at minimum pretty much. We've got mode on, subsonic is on. Now I want to change some of that. I want to change some of that up. There we go. So we want subsonic mode off. We want high pass, want that full. We want that full range. Bass boost down, low pass down. Level, let's have it up at about just a third, and we want normal polarity on the phase. Okay, moment of truth then. Is this amplifier going to help us or not? Or is it going to be the same old headaches as the other one? Please, dear Lord, let there be audio on the outputs. Uh, 50 Hertz is going in. Let's see. Let's see. I haven't heard any relays click in yet. So the relays don't seem to work. Do we have any audio though before the... Yes! My good gentleman. We do have audio. Okay, that is fantastic news. Okay, so we don't have audio on the terminals, but that's fine. The relays aren't clicking in for some reason. That's an easy fix. That's an easy fix. If we probe after the first set of inductors, the first filters, we can see quite clearly here that we do indeed have audio outputs from this amplifier, which means that we can use this amplifier to diagnose our problems with the other one, with the other one's preamplifier section. Fantastic news. Okay, we can get to the relay circuit later. Let me just see if turning my my voltage up a touch actually helps out with that, because I'm only running 10.5 volts at the moment here, which could be one of the reasons why we don't have any relays. So let's go up a little bit. 12 volts. Relays are still. Oh no! Wait, have they come on? I think the relays have come on now. Okay, so the relays not engaging was just due to low voltage. So yes, this amplifier now fucking works. Awesome. Okay. Awesome. Awesome. Fucking yes. So this is our key. This is our key to figuring out the other one. Okay. So now what I want to do is I want to power the amplifier up. Let's turn the voltage back down again, because how hot are these output FETs getting? Okay, they're staying nice and cold. Okay, so even though the drive doesn't look that pretty, they are staying cold, which is good. So that means that I can leave the amplifier powered up without any risk of overheating anything on the output FETs. That's fine. Excellent stuff. So, one question I do have though is the screen working? Does the screen work? Because if the screen works, that will be the best, because that means that we can swap out the level shifter. Okay, so the screen is just on here. HP Manager. I want to speak to the HP Manager, please. So this should light up blue, and it should come on and tell us a bit about the amplifier's current status. Yes, check. So it goes through the health check mode, and then it comes on as 10.8 volts. There's no green, there's no light, there's no blue light though. There should be a little on light though there. That doesn't seem to work. That's funny. I mean, that's at this point, that's pretty minor, right? The amplifier works. That's pretty minor. We can look into that later. It could just be a bad LED, or could just be that the solder joint is bad or something like that. That's pretty minor at this point. Actually, let's just see if we can figure out why the LED's not on this. So the on LED is the far top one. So that's going to be this one just right here. So let's see, if we have voltage drop across these pins for the LED. So if we have a difference in voltage between these two pins, then the LED should be coming on, and it's just quite obvious that there's a problem with the LED itself. Bloody remote terminals come out again. Okay. Oh, actually, no. There's actually a problem with the supply. So there's no voltage across. Okay. All right. That's a bit more in depth to figure out why that LED isn't working, but that's something for later. That's something for later. We have now a working amplifier that we can use to figure out the other one. So, yeah. I fixed my share of amps that the owner thought was not working due to the LED. Yes! Yes, I have the same thing happen. And I actually am... I'm guilty of being that customer as well. Who remembers, who's been subscribed to my channel for long enough, when I got the 3 Crown Macrotech amplifiers, the 2Ks. When I bought those, only one of them worked. And so I got all 3. So I obviously powered them up to test them. The first one that I powered up, tested, worked beautifully. Good audio, great amplifier. I was like, yes, this is great. Maybe all these work. I powered up the second one, and the lights on the front weren't. They didn't. You know, the power light was missing, and the red light was on. At this point, I didn't quite understand what the lights on those Crown amplifiers meant, but I knew what they should do based on the working one. So the lights weren't quite doing what they were supposed to be doing. So I was like, that's a bit strange. So I hooked up a speaker and I played a song, and I turned the amplifier up. And as I turned the amplifier up, I heard bum, 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 like capacitor, poo, 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 from inside the amplifier, and a bit of smoke. I was like, oh, fuck! So I turned it off, and I was like, oh, Jesus, okay, that's not good. So then the third one that I plugged it in and turned it on, and as soon as I turned it on, I noticed that the lights weren't in the correct place again. The same as the second one that went pop. So I was like, nope, fuck that. You know, my experience then was, if the lights aren't doing the right thing, then there's a problem with the amp and you mustn't use it because it will go pop. So it actually turned out, so I sent the two second and third ones to repair. The second one, yeah, did have a bunch of issues, but the third one, actually the amplifier worked fine, just the LEDs on the front weren't working properly. So I did have 2 working amplifiers, but yeah, the third one just looked like it was wrong because the LEDs, and from my experience with the second one going pop. Can you repeat the noises the first amp made? Yeah, the first amp was like, skia, boom, 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 boom. That's what the second amp went like. Okay, right then. Exciting times. So, provided this amplifier doesn't kill these 074s, we are in for a good time this evening, gentlemen. Provided it doesn't kill these, we are in for a good time. So what I want to do now is I want to follow some audio. I want to plug the RCA back into here, into the preamp, and I want to follow it through the section that we were looking at yesterday on the other amplifier. So what we discovered yesterday from the other amplifier was that the audio comes out of pin 5 of the filter board up here. It then goes over to R34M, which then goes through a resistor, and it goes into the input of an operational amplifier, then the inverting input here. Then comes out of the op-amp output here. We didn't have any audio on this side of the op-amp on the other board, so we're going to check that. First of all, see if there's any audio on the other side. Then we're going to follow the audio out of this pin. Now, on the other amplifier, it went through this 680 ohm resistor. Then it went over here to this 100 kilo ohm resistor, which then that goes to ground, but the signal also goes through this capacitor, C16M. It then goes over here to R32M. Now, on the other board, on the other side of R32M is ground. So before we power her up anymore, let's see, is that the same on this one? Do we have a ground connection to the other side of I think it's R32M, or was it R29M? I can't remember. Let's just check both of these. So we have ground over here. Let's remove my RCA so we're not showing ground. So output ground is the speaker negative terminal, which is this one over here. And we had continuity to ground on here. Okay, so we do have continuity on R32M. Okay, that is supposed to be there. R29M, we also have continuity to ground. So this is what's confusing me. Where the fuck does the audio go? Because yesterday I was tracing the audio through the board on the other one, and I only really found a couple of ways that the audio could go, and I was very confused. It goes into this TL072, it comes out, and then it just kind of seems to fuck off to ground. But obviously this amplifier is working, so yeah, very, very, very strange. But okay, let's power it up and let's see whether the audio is present on the other side of this operational amplifier, this 072N. And then we'll marry that up and we'll get the second amp up on the workbench at the same time, and we'll have a look at the two amplifiers together. So let's kick her into operation once more, gentlemen. Get her fired up and ready to go. Output switching is present. 2.1 amps on the current draw. We have... uh-oh. Wait, why is there no signal here? Uh-oh. Oh, my fault. I plugged the RCA into the pre-out. That's my bad. My bad! Sorry. Alright, here we go. So we have nice sine waves on this resistor, which is where it was before. Now we don't have a sine wave on the input. That's normal. I think that's normal. On the output, we have a sine wave. Now, where else do we have a sine wave on this op-amp? Do we have it anywhere else? No, we don't. Okay, we don't have a sine wave, so it's not using the second side of this operational amplifier. We have a sine wave on R24M on both sides. R28M, we have it on that side, but not on the 100K side. After C16M, we have it. And then on R32, we don't. R29, we do. After R29, we don't. Okay, so I'm obviously missing something visual. I'm missing a visual somewhere into this amp, like on the other amplifier. I have obviously missed a visual trace of where the signal goes. However, that could another thing that we looked at yesterday is we wondered whether there's an issue with this top filter board, because yesterday we only had sine wave output on pin number 5. So let's see whether we have the same thing here. Do we only have audio output on pin 5, or is there supposed to be audio output on some of the other pins also? Turn it back on again. Switching active. Sine wave active on the resistor. Okay, so pins of the this bad boy then. Okay, pin number 1, we have nothing. Pin number 2, we have 4.8. Pin number 3, we have nothing. 4, we have nothing. 5 should be the audio, which it is. 6 is negative 12. 7, positive 12. 8 is positive 5. And 9 is nothing. Okay, cool. So we're not supposed to get any multiple audio outputs from here. And I think on the other side here, we just had 2 outputs. So on this side, we just had number 3 and 4 as audio outputs. So let's just confirm that as well. Power her on again. I'm a bit worried about keep powering on and off this amplifier. You know, doesn't like being powered on and off, on and off, on and off all the time. So pin number 3 is audio, 4 is audio, 5 is nothing, 6 is de nada, 7 es de nada, no está aquí, o no, número 8 y 9 no está aquí, nada está aquí. So we have nothing there. So that then, fucking hell, my tester tape has come off my hat. That shows us then that the filter board on the other amp is probably absolutely fine as well. Let me grab some of this big boy duct tape. Try and get this wire stuck on here a bit better. So that's a good thing. Okay, so the issue then on the other one is on the main board somewhere. Okay. Also, our 074 CNs are surviving so far on this board. We haven't got any DC leakage anymore. You know, it's early days yet. We could still get some DC leakage. It is early days yet, but so far they are surviving, which is good. Saludos desde Argentina. I don't know if I said that right. Bervids. Me encantaría que puedes explicar un poco en español. Sí, para el problema es que mi español no es más bueno de explain muchos de audio amplificadores cosas. I don't know the Spanish words for like MOSFETs and stuff. Like in school we just learned lots of Spanish that was like, you know, for getting around town and ordering cheeseburgers and what's in your pencil case and shit like that. We didn't really learn much. So I did do a video where I repaired an amplifier purely in Spanish, but trust me, there was a freaking lot of Google Translate in that. I did not all do that from the top of my head. That was a lot of Google Translate. Check the bottom of the PCB for damage. Also, yeah, the other amplifier, we'll check that out in a minute, but it doesn't have any damage on the bottom of the PCB by the looks of it. So, alright then. So, yes, we definitely then are looking for the audio to go somewhere else. So, whilst we were tracing the audio on the other board, we were obviously missing something. We're missing somewhere that the audio is supposed to go. Now, what do we do with this one? So this one obviously works. The pain in the arse is that this board, this filter board, is kind of in the way. What I want to do is I want to probe underneath it for audio. I want to kind of follow the traces into the driver board. So that obviously at some point the audio makes its way into the driver board. And I think I figured out that the audio makes its way into driver board pin number 6. So you see here we've got pins 2, 1, 2, 3, 4, 5, 6. Pin number 6 has PWM on it, and I'm pretty sure that the sine wave is applied to said PWM, and that's what it generates the pulses from that. So I think that the sine wave goes into pin number 6 of this. So what I need to do is trace backwards then from pin 6 to the rest of the board here. But let's just confirm that. Let's power this board up one more time with the signal going in, and let's look very, very closely for which of these pins on this janky looking driver board has the audio wave on it. And I'm going to try not to short out any pins, because that would be the worst thing in the world, wouldn't it, if I shorted out some pins here. Okay, switching is active. We have a sine wave on the outputs as normal. Okay, so pin number 1 then. Pin number 1 has some DC. Pin number 2 has some DC. Pin number 3 has nothing, nada. Pin number 4 has nothing. Pin number 5 has DC. Pin number 6 has PWM, but pin number 6 has PWM, but I believe with a sine wave on it as well. So I think the audio does go into pin number 6. Now, in order to confirm that, and in order to this time trace backwards from the audio board, from the driver board into the drive circuit, into the, fuck's sake, right, we're going to trace backwards from the driver board into the preamplifier section now. In order to do that, I'm going to take the other board, the one that we were working on yesterday, and we are going to remove the driver board from the amplifier from yesterday, and by removing it we're going to see quite clearly which pin has audio on it, and then we can trace back from that pin through the rest of the drive circuit, through the rest of the preamp circuit, to find our bad component, what's going on there. So let's take this lovely repaired amplifier, put this down to one side. And let's get our one from yesterday that was giving me mad headaches, which is just here. Okay, welcome back. Welcome back to the workbench, my friend. Greetings from Sweden, Henrik. Good to see you here, buddy. Thanks for joining the stream. Greetings from Sweden. What temperature is it there right now? I understood the word amplifier. I failed Spanish in high school. I did not bad in Spanish in high school, but I didn't take it further than high school. Beverage, is there a muting circuit? Very possibly. However, the interesting thing about the board that we're working on last night is that So we don't get any audio through the main RCA inputs. However, we do get the amplifier works perfectly normally when we use the slave input. So when we give audio into the slave input, which bypasses most of the preamplifier section, we do get audio. So a muting circuit, the way a muting circuit works is it would normally mute the output section by sending the drive ICs, the IRS21844S, into shutdown mode, which disables a PWM on the FETs. That's normally how the muting circuits work in these, and that's not what's happening here. So I think that it's just something that's preventing the audio signal from getting from one trace to the next. It could even be a bad via. Hey, you know what, guys? Look at these vias. Let me give you this camera. We're going to zoom right in here so you can get a nice zoom in picture of this board right here. Now let's take a look at some of these vias. So things like this, get my probe. Things like this, so this is a via, and that transfers signal or electricity from one side of the board to the other. And sometimes these just corrode, go bad, and they don't actually transfer any any signal or anything from the top to the bottom of the board. So if one of these has gone bad, then that could definitely be giving us the kind of headaches that we're experiencing. Although it doesn't explain why the op amps are dying. So I think the first thing that we're going to do with this amp is we're going to replace the op amps here with the ones from the donor board, which seem to they seem to work okay on the other one that we just fixed. So let's grab some more of these donor board ones here. First of all, turn my soldering iron back on. Let's preheat this board a little bit. Get some heat into this board. You're a good source for learning. Can I send overseas from Belgium? I have a Kenwood amp that only does bass on the second channel. 1 second. Here we go. Okay, a couple of questions then. So, can you send me an amplifier from Belgium? I will entertain the idea of having you send me an amplifier from Belgium. Get a shipping quote, message me on my BearViz Facebook page, get a shipping quote, but I imagine the shipping might make it not worth it. The shipping is pretty expensive from overseas on amplifiers, the weight and stuff like that. So, make sure you think it's worth it first, because obviously you're going to have to pay for the shipping from Belgium, any import fees that I get, on the amplifier coming in from Belgium. Then you're going to have to pay for the repair. Then you're going to have to pay for it to be shipped back to Belgium. So obviously just work out a rough idea of all those costs and decide whether you really think it's worth it. Alternatively, I can try and help you fix that amplifier remotely, which obviously saves on all the shipping costs and it also saves on my repair bill. So give that a go first, perhaps. If you feel like confident enough to use a soldering iron and you've got an oscilloscope or a multimeter, etc., then maybe watch a few of my videos. Generally, if it's a Class AB amplifier, smaller Class AB amplifiers don't generally kill the drive circuit, so you can do a really nice easy repair just by replacing the output transistors most of the time, and the things, they just work. So maybe give that a go first. If you don't have any luck with that, then give me a shout. There was another question that said, what can I replace? Here we go. Where's that gone? Sam, can you let me know what I can use to replace the IC, which is HIP 4080? Unfortunately, you can't. If you've got an amplifier that uses a HIP 4080, you must use the original part. That is a one of a kind. That is a one of a kind Class D drive IC. And it's a very old one. They're not really made anymore, and they're bloody expensive. They're like £5 each here in the UK if you want to replace one of those. Not only are they very expensive, but they're also very fragile. If the amplifier is not repaired properly, then those chips will die 90% of the time if the output FETs fail in those amplifiers. So yeah, if you're repairing an amplifier with a HIP 4080, then make sure that you are 1,000,000% certain that the amplifier has no bad gate resistors, for example, anything stupid that can cause the output FETs to die again, before you go fitting the new HIP 4080 chip with the MOSFETs in. because they are extremely delicate chips and they're very expensive. You know, if you end up replacing 3 of them, that's £15 already just gone on that chip. So on those chips. But yeah, there aren't any alternatives to those, unfortunately. You do have to use the original number. Good to see some of you other guys in the live chat jumping in on some of those questions and answers. There's a lot of knowledgeable people here in the chat, guys. I'm sure many people far more knowledgeable than I here. So good to see you jumping in on some Q&As. There we go. Okay, so there's 2 of the same 074s that we used on the other one that seem to hold up quite nicely. So let's remove the bad one, or the bad ones, from this one that kept dying last night. So get some heat into this board as well. Can high voltage RCA input damage an amplifier? One second. So, feeding too much RCA signal into an amplifier generally is not going to kill it, because you know, feeding sort of 5 or 8 volts of RCA signal, generally the amplifier is going to be able to handle that. So the reason that the amplifier is probably going to be able to handle that is because the op amps that the signal there is going into, they have VCC plus minus like 12 or 15 volts. So the only time when those might get damaged is when your input signal exceeds the VCC quite considerably there. But yes, so generally no, you can't damage your amplifier by putting too high signal, RCA signal in, unless obviously it's like really high voltage. Like if you connect up 12 volts DC to your RCAs, then yeah, that's potentially going to cause some damage, you know, especially because 12 volts DC is quite close to the VCC voltage of the op amp. So I wouldn't like to say whether that would survive or not. Probably not. So that's the two 074s out of this one. So we're going to place our 2 replacements in that are from a donor board. So they, you know, the donor board, the donor board they came from has been an amplifier that's been running absolutely fine. Apart, you know, the preamp section wasn't the issue in the donor amp. So these should be fine. They're not brand new, but it's kind of good that they're not brand new in a way, because I'm wondering whether I got a bad batch of 074Cs or something. Maybe they were fakes. I don't know. Bit of a weird one that they keep dying like that for no reason. Someone was saying to me earlier that it's, you know, pretty uncommon. It'd be pretty rare to get like a bad batch of op amps. You know, that's not really something that's heard of as much as a bad batch of MOSFETs, for example. But I don't know. It's kind of one of the only things that I've got left to really consider here. Ah, my man, Fat Boy Ick 11. Hello, Keith from Houston tuning in. I've been subscribed for over 10 years. Jesus Christ, I'm so grateful for the knowledge you share with everyone. You've motivated me to start my own channel, SPL Society. Guys, go give this guy a subscribe. Thank you massively for the 20. You earn my subscription for sure. Let's see if we can find it. Can we find SPL Society? YouTube.com / actually, I don't think we'll get a /. I think it's probably just going to be a channel with a... Let's have a look. SPL Society. Can we filter by channel? There we go. I imagine it's probably this top one. So guys, go ahead and give this guy a subscribe. Why not? Thank you very much for the 20. And we'll check out your content, my man. Okay, new op amps going in. I say new. Donor op amps going in. Okay. Should be good now to go in. Legs all should be lined up. And in we go. They're a little bit wide out. Squeeze them together just a touch. They're staying 2 meters apart as they should, but 2 meters apart is no good for operational amplification, gentlemen. There we are, literally just about squeezed in there. Tight fit, just how we like it. Over we go, and solder ruby. Now, fortunately, there's plenty of flux on the board here from removing these multiple times yesterday. Now, I'm also, just while I'm here and I've got my iron hot, the vias that I pointed out to you earlier on this board, I'm just going to, while my iron is hot, plop some fresh solder into the via, which, if there is any poor connections in the vias, should kind of like, you know, having some fresh solder in there should you know, make a decent connection again. So just while we're here, while we're remembering it, let's drop in fresh solder into a bunch of these vias here that we see that are open, that have open holes. This is a thing that I see quite a lot on older amplifiers, specifically solid audio. Solid audio F2500D suffers greatly from bad vias in the from bad vias in the driver board. Very, very bad. It suffers very badly from that. Now, these amplifiers I don't believe are as old as that, but I would still like to just remove that as a possibility while we're here, and just kind of tidy up any solder joints that, you know, look a bit stanky. This one there doesn't look so great. Okay, cool. I think we're good. I think we're mostly good with the vias. DJ Impulsion, dude, thank you very much for the 5. That's wicked. Cheers for that. Recently discovered your channel. Love what you do. Plenty to learn from your videos and live streams. Thanks for all that you do. That's no problem at all, man. I get great pleasure in doing these live streams. Wouldn't do them otherwise. So you know, it's great to see that some people can you know, benefit and learn from it. Just kind of doing what I do, and just happen to be live streaming at the same time. So it's really awesome that you guys are enjoying seeing what you're seeing. Okay. So now then, what we're going to do is we're going to remove the output driver board. So the output driver board in this amplifier is right here. I want to remove this for two reasons. Reason number one is it prevents the output section from coming on every time that we power the board up. With the output section coming on every time we power the board up, you know, it's not so good for the output feds to keep coming on, off, on, off, on, off, especially with no load connected across the speaker terminals. So it disables the output section for a start, which is good. Second good thing about it is that we can check we can trace back the audio input pin on this amplifier and see where the audio is supposed to come from on this board. So let's preheat the driver board area slightly here. Good. And now we should be able to just roll up and flood these legs and pull out from the other side. Flood, flood, flood. The weather forecast is inclement on this driver board. There we go. Ian, that's a good word for you. Inclement. That's not slang, by the way. It's not. It's just like an old. That's just like a English word for wet weather, inclement weather. If it's raining outside, fucking hell, lads, it's a bit inclement outside, isn't it, eh? Actually says it in the in King's Cross Station in London. If you go to London, you visit King's Cross train station. There is a tannoy announcement that will say, due to today's inclement weather. Something like, please take care when you're walking around, and I think it's just basically don't trip over and sue us or something. Okay, why is this not coming out? We are plenty hot enough. Maybe this driver board actually is glued down slightly. Are there any glue joints? No, I don't see any glue joints. All right, this is definitely hot enough. Let me crank the solder. I've got the soldering iron back down at like 380 degrees because I'm just trying to save it a little bit. I don't want to kill this tip as quickly as the other one did with the 480 all the time. There we go, it's starting to come off now. Just needed a little touch more heat in the iron. That's the thing, this iron works so great at 480, but I just don't think the tips last that well at 480. Screw it, we're going up to 480. What are we on? 430 something at the moment. Oh, there's so much better up at 480. There we go. Instantaneously, massively improved that. So yeah, we have our driver board out, no pulled veers as always. However, we will need to use our solder wick today, gentlemen. We will need to use our solder wick today on these legs because as you can see, there's like, because I flooded it, lots of that solder got through obviously onto the legs. So this isn't going to go back in the holes nicely because there's lots of solder on it. So what we can do, have any of you never seen solder wick in action? This is the point where I want to use my solder wick and now can't find it. What did I do with that bitchin' solder wick? Here we go, found it. So yeah, solder wick, pretty awesome stuff. All you do, load up your selected area with a little bit of flux. Just a little bit, don't need too much. A little bit of flux. A little bit of flux. A little bit of flux. Just a touch. Then we're going to turn our soldering iron down a bit. We don't need it up at 480 again. We just whack it down to about 390. Then lay your wick across the legs. That's wick, guys. That's wick. Lay your wick on the legs. Then push down firmly. And you will see that all of that solder that's on the legs just wicks away into the wick and leaves you with nice clean legs. Beautiful, beautiful. There we go. So now it's much better. That's going to go back through the holes on the board much easier than it would have before. Yo, Matt went for a KFC. The second amplifier that we started looking at this evening works fine. Just needed 2 new 074Cs, which was the same as this issue. So this one, so far we just removed the output driver card and replaced these 074Cs. Now we're going to power it up and we're going to try and use both amplifiers now to trace where we lose the audio in this one. Just before we do that though, I'm going to suck the holes on this driver board while we've got a nice hot iron and a bit of heat in the board. Might as well take advantage of that scenario. So that we don't have to do it later. So what I will do is I will tell you what was confusing me earlier, yesterday. So yesterday, after the stream finished, I spent probably, I don't know, 10 minutes more just looking at a few things that were in the back of my mind on this amplifier after the stream finished. And I'll go through what I did yesterday. I think I did a few. I did a couple more things. I didn't really do much more actually. I didn't make any progress last night after the stream. But I just kind of checked a couple of things. Yes, these solder suckers spew metal shavings everywhere and it is so annoying. Matt, I could not agree more. It is very frustrating. Very annoying. I am on the hunt for a Hacko something 301. What is it? Hacko something 301, which is the desoldering gun. However, I can't seem to get... So in the UK, you can buy that. You can buy the desoldering gun. However, it is £300. Now in the US, you can get the Hacko 301. I think it's FR 301. You can get the Hacko FR 301 for about 280 bucks, I think. And that 280 bucks equates to about £200 or £190. So I am paying almost double because I live in the UK, which freaking sucks. So I've just been waiting to try and see if one comes up second hand. I don't want to pay £300 for something that costs should only cost me like 180, 190 just because I live in the UK. So I've been waiting to try and grab one. A few very kind gentlemen have offered to grab one for me in the US, and then I pay them and cover postage, which would work out less. The problem is in the US, you can only get the I'm pretty sure you can only get the 120 volt version, whereas I need the 240 volt. So the only difference is that heating element is the 240 volt heating element version, which I can't seem to find in the UK. when we do a shed tour, I could do a little bit of a shed tour tonight. My cameras don't reach very far, but I can kind of point at things and be like, yep, that's that, that's that, that's that. On the solder sucker, what's the silicon thingy that's on there? Yeah, so the solder sucker has a silicon thingy on it, which makes sucking much easier, because obviously this is the standard tip, which is just plastic, and it's very difficult you can't get an airtight seal on what you're doing, so you're just relying on the air rushing by. But having the silicon tip allows you to actually put this over the iron, so the iron can kind of actually be under there at the same time, and you can be heating it and suck it at the same time. Yeah, it really improves it. Everyone that has tried that with the silicon tip says that it's so much better, and yeah, it is way much better because it creates an airtight seal around what you're trying to suck. Thoughts on Kenwood? Yes, lovely stuff. They have made some shit over the years, but generally they're really awesome, and they made their own circuits. You know, their circuit designs are unique. They're bespoke circuits. They're not just off-the-shelf stuff for the most part. They have made some off-the-shelf shit, don't get me wrong, over the years, but in general, this stuff is pretty cool. Okay, so now that we have the driver card removed, this is my thought process going forward. We already know that this amplifier works beautifully when using the slave input RCA. Now, that means that audio is making its way from the slave input RCA through the preamp board somewhere and getting into the driver board somewhere. So what I want to do is I want to see which pin is the audio input pin for the output driver card. Then, because the audio input pin for the slave input and the main input it's going to be the same. The only difference is that the main one goes through the filters first and the slave one doesn't. So whichever pin is the audio input pin is the same, whether I use the slave input or the main RCA input. So what I can do then is, once I figured out which one is the audio input pin, I can trace backwards from here to the rest of the circuit and figure out where our problem lies. So the first thing that we want to do then is have a look at, remind myself which one is input, slave input and master output. So slave input is this top one, and for slave input we want to put the little clicky button inwards. Now we want to power this amplifier up and crank up the gain, because we haven't got any output FETs. You know, the output driver board is detached, which means that we can very happily just crank up the gain here to get some nice high amplitude signal on the traces, just to make it easier to see which pins are which is good. And then we can follow the audio wave through the board and then see where it comes from, and then try and find where the problem lies. So power is in. Let's turn the power supply on. 10 volts, 4.5 amps. Don't need that much actually. Let's go crank it down to about 2.8, 2.7. And let's see then which pin is our audio. So it's probably going to be one of these ones in the middle here, right? Because it wouldn't be any of the ones on either side, because they're for driving the FETs and stuff. So let's just check there's no metal shavings underneath the board. Looking good. And here we go. Amplifier is on. We have 1 amp worth of current draw, which is good. Power supply is active. So we should have some RCA signal just about here coming in. Yep, looks like, let's just double check. Okay, so we've got some low amplitude signal. Let's crank that up. Okay, so we've got a nice high amplitude signal going in. Plug that into the board. Now we want to see which pin, where is that audio on the actual amplifier? Pin, no, not there, not there. Woof, okay, woo. It is right about there. And that is very clipped. So let's turn that down a bit. There we go. There is our audio input. We are on pin number 4. Pin number 4. That's our audio input wave to the driver board. Fantastic stuff. that is actually much better. I thought it was going to be one of the other pins. So that's awesome. That's awesome. So now we need to trace that back then and figure out where exactly that comes from. Thoughts on bass habit amps? Never heard of bass habit. Sounds like bass face. It's like a budget brand using the Chinese boards. Okay, so pin number 4 then, just here. We want to trace that. Now the trace must be on the bottom of the board because we don't have anything on the top. So let's first of all take our pull down resistors. We want to get rid of the rail voltage that's inside the board while we're doing this. So let's do this. We'll get a little spark on here probably. No spark, but we just drain the rail voltage, get that down, turn the main power supply off, and remove the main wires here from the amplifier. Okay, so pin number 4 then. Pin number 4 then. So that's the third one from the top, which is going to then be the third one from the bottom. So pin number 4 is just there. So with our multimeter on diode continuity mode, yep. We go back from pin 4, la 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 la, and we go to this via right here. You know what, it could have been a via. Maybe I should turn the amplifier on now that I resoldered some of these vias and just see whether we get audio input from the main RCAs. So it goes to this via right here. Flip her over again. Trace it from the top now. Pin number 4. What was that? Which via was that? This one here. So we jump from there over to there. Then where does it go? Let's just take a guess let's take a guess. Try and find. It goes to there. Okay, so we go there. Then it jumps over to here. Then from here, it jumps over to... Where does it go? From there, it jumps over to there. And from there, it jumps over to there. And then from there, it jumps over to there. From there, it goes to here. R133. Okay. Now, is R133 responsible for slave input only? Because I imagine that at some point they will parallel. You understand what I'm saying? So at some point along the way to pin 4, there will be a kind of a Y split or a fork off where it goes to either here or here. So what we should probably do is we should probably look at some of these traces and see whether there's any fork offs. Fork off! This amp can fork off, I'll tell you that. So at the moment we go to R133. Then on the other side of R133, it goes to R131, which... Wait, what? No. R131 goes to this resistor here. On the other side of this resistor, it goes to this resistor here. And that probably then goes to ground. Yep. So it must be on this one here. That probably then goes to here. Then over this way. And yes, we have this TL's... It's probably this one. Okay, so that is probably... We've just followed the pathway back to the slave input here. So at some point, this is probably going to fork off into coming from the main one. Or maybe even, actually, maybe even this 072C is responsible for having not only the slave input on it, but also the main one. So maybe one side of this op amp has the slave input on it, and the other side has the main input on it. So let's just go over to the bottom of the board. Let's trace it from the back now, and let's see whether we can see any Y splits or forks. So we know that the it went there. Then after that, it went over. Where did it go after that? Remind myself there. Then it went over top of the board. might have to just do it from this side. So here I'm going to have to keep flipping it now, like a flipping pancake. So pin 4, there. Then it went over to that one, which is then this one. Aha! There is a fork. There is a fork. Okay, so you can see here that this trace, half of it goes off this way, and half of it goes off this way. So we have another component here. Now what's that? That is a R201A. And that is on the multimeter. What does that read as? That is brown, green, yellow, gold. That's probably going to be a really freaking high value resistor. Does that go to ground actually? That might just be a grounded resistor. Does that go to ground? That just might be a signal cleaning up resistor. No, it doesn't go to ground. But that is a pretty thick trace. Where's that going to? Why would that... Okay, that's interesting. I don't think that that's anything to do with signal. I don't necessarily think that's anything to do with signal. See, this is a problem. When we have a Y split, I'm going to ignore that Y split just for now. I'm just going to ignore that Y split for now and see if there's another one anywhere else. So that goes there. Then we have over here. Then we go from here to over across downwards to here, then to here. Then after that one, we go across slightly over to here. Then we go to here. Then after that one, okay, R35M it goes to. We do have continuity to R35M. So let's go pin number 4, R35M. Oh no, up here, not that one. Just bear with me, guys. I'm going to come to you in a minute and explain what I'm doing. I'm just kind of on a bit of a tracing roll here. Just very, very concentrational. That one there. That goes down here. Then from here, next to those three, we go just across slightly to here. Then here, across slightly. We go over there, and that goes, okay, so there's no other fork. Okay, so what we've discovered then is we have found that pin number 4, the audio input, one trace goes all the way over here to, ends up at this op amp, this TL072C, I believe, because it goes over here, and then this capacitor output, I believe, will end up going into the one of the legs of the op amp. Yeah, it goes into, yeah. So pin 4 is connected to the output here of this one. Pin number 1 of this 072C. Okay, so that is responsible for the slave output. Okay, so the other way that it goes, we end up with signal. We end up with a kind of fork in the line here that ends up on R201A. Then on the other side of R201A, it's very curious because this then forks off, and we have a trace down here. Which, that one, where does that go? That then goes over here. See, that all just seems to go to ground after that. There just seems to be a bunch of ground after that one. So I don't think that contains any kind of signal or anything. So, yeah, interesting. I wonder... You know what I wonder? Do you know what I wonder? Are any of these connected to ground? No. Guys, I think I might have an idea here. So, when you are slave mastering your amplifier, okay, in order for strap mode to work, your amplifier, when you feed signal into the slave input, the amplifier needs to invert the phase. It needs to flip the polarity of the signal that you're feeding it into the slave input so that the output of the slave amplifier is 180 degrees flipped with the master amplifier. That's how push-pull in slave master works. So over here we have a single 072C op amp, okay? And on the output, here we have the output which goes to the driver board. So the inverting op amp, so the op amp output number 1, which is leg number 1 of this op amp, this TL72C, this goes to the driver board. Now, pins 2 and 3, one of these is inverting input, one of these is non-inverting input. So I wonder whether the inverting input is tied to the slave input and the non-inverting input is tied to the main RCA input. Because then what that will mean is that with the main RCA input on the non-inverting input here, the output of pin 1 will be in phase with the signal coming into the RCA. But with the input, so when we remove that RCA completely, that then puts this non-inverting to ground. Then we put some signal on the inverting, which then flips it 180 degree out of phase and puts it into, puts 180 degrees out of phase onto the output. So I wonder whether that's how it's working. So in order to confirm that, what we're going to need to do is get the amplifier that works and see what kind of sine waves we have on this final 072C before it goes to the drive board here. Just before we do that though, I am going to power this amplifier up one last time with the RCAs plugged into the normal RCA input. Just because I did do some soldering on some of the vias on the bottom of this board, I want to see if that made any difference. So according to what we have done so far, this amplifier doesn't work with normal RCA input, okay? It didn't work before with normal RCA input. So if we put some RCA into the normal RCA input just here, onto this block here, we technically shouldn't get any audio on pin number 4 of the driver card here. If we do, then it means that our soldering of the vias has actually fixed the problem. If we don't get anything there, then we need to grab the other working amplifier and figure out where the sine wave comes from for the normal side. Let's power her up and let's take a look. One second. MIDI to key, MIDI to key, MIDI to key. There we go. So what I'm looking for here is a sine wave at 50-ish hertz, something like that. Okay. Oh, the amplifier just went into protection. Did it? Yeah. Okay, no, I just removed the remote slightly. So I don't have any signal there. Okay. Well, that's a good thing, because that means that it hasn't magically fixed itself. That's fine. So we don't have any signal there on pin 4. So this amplifier, yeah, still not getting any... Oh, actually, hang on a minute. No, the reason why we might not have any signal is because we don't have the freaking filter board in. So let's put the filter board back in first, because that would be a reason why we also don't have signal there. Let's put the filter board back in, because that will be stopping signal from getting there. So let's put that, shove that back in here. Because that's a false negative, that is. Because we took the filter board out. So obviously there's not going to be any signal without the filter board in, is there? Okay, filter board's back in. Now we just need to grab like a screwdriver to hold this up, because otherwise it will push that out. There we go, like that. Get that in there nicely. So do we now have signal on pin 4? Just there. Hey? What? Why do I have 3 volts DC on pin 4 and the amplifier not coming on now? What? What is going on? Hey? What? Why putting the filter board in? Why is that stopping the amplifier from coming on? What? What? Nani? Actually, you know what? The tolerances are pretty tight. I wonder, because I filled in some of these solder blobs, so I wonder actually whether one of these solder blobs is actually protruding slightly and touching one of the potentiometers. That could be what's happening. Because obviously I filled in these boards with solder, so I just want to desolderize those slightly, just in case that they're touching any of the potentiometers in that filter board there. Flatten those down. Okay, is there any other vias popping up now? Don't think so. Okay. Let's put this back in again. Make sure that that's lined up correctly with the right holes and the right pins. Yep, good to go that side. Good to go that side. I tell you what, this one is like a new fault every time we power it up. Okay. Now what we got? Okay, now it's weird. Yeah, that's what it was then. What a weird thing for how the tolerances are so tight on that. The tiny little like round top of the solder blob on the via was actually touching one of the potentiometer cases, preventing it from coming on. How freaking crazy is that? What tight tolerances does this have? Anyway, so now it comes on. So let's see, do we have any sine wave on pin 4? Nope, so still no sine wave on pin 4, which means that, yes, we still have no output then from this amplifier. That's fine. That's fine. So we still have the issue, which is fine. That's absolutely fine. We don't have any DC on this resistor yet, which is cool. We do have sine wave output on there. Let's have a look on this TL074. Okay, so we don't have any input to this one over here. So this TL072, which is what the where the slave audio comes from. Oh shit! I just flicked the master switch. Ooh! So maybe the vias was the problem, because I just flicked the master switch because I forgot I left it on slave. Now we have audio on pin 4 of the driver board. So maybe it was bad vias all along then. Okay then. I'm just curious, before I shove the driver board back in and power it up and see if we have audio, I'm just curious, was my inkling about this 072C up on this side, was that actually accurate? Was that correct? With the switch flicked, do we have sine wave on the non-inverting input of this op-amp up here? Well, we have something. Yeah, we have the sine wave on the output of that. I think we do, you know. Now, the way that op-amps work is that by probing the inverting and non-inverting input, you don't usually actually see a wave on the scope, because the current is so low that it is actually inducing a current inside the op-amp, but it's just so low that you can't see it on your oscilloscope. So I think that my guess there was correct. That 072C is using the inverted input for slave input, inverting it obviously to the output, and he's using the non-inverting input for after the filtration circuit of the main input to send it to the driver board. Okay, right, now is the chance, now is the time that we find out, because we have audio on pin 4, so if there's audio on pin 4 of the driver board, that should then be causing there to be audio on the driver board, PWM and output. Okay, let's see, exciting stuff. Oh yes. Now this amplifier still isn't going to be 100% fixed yet, because we still have a dead level shifter chip on here. The level shifter chip for the screen on the top, that seemed to die. So what I could do, guys, what do you reckon? Give me choice A or choice B, just like we did on the other live stream. Choice A, if this works, so this is provided this works. If this works, choice A, leave it working for tonight, order a brand new level shifter and fit it and see what happens then. That'll be another stream because I haven't got one of those level shifters. Or option B is to desolder the level shifter from the working amp, drop it into this one and see if the screen works then. Obviously doing that could risk damaging the level shifter if it is sensitive to heat. In which case, if that does happen, I would then need to buy two. Not such a big deal, that's fine. I imagine they're probably quite cheap anyway. But obviously by doing option B, we get to see whether this amplifier is fully fixed with everything working this evening. But option A assumes that it's going to be fixed with a new level shifter after we've ordered one. I think most of you guys, A, B, A, B, A. There's more A's than there are B's. So we're gonna leave it. And order a level shifter. And then what we'll do on another live stream on in December, in a few days time, maybe next week, as part of the live stream, right at the start, I'll drop the new level shifter in and see if it works or not, and then we'll move on to whatever amplifier we were going to be working on for that live stream anyway. So that's what we'll do. That will be a small cliffhanger. Actually, but let's not get ahead of ourselves. Let's not get ahead of ourselves too quickly here, because we still don't know for 100% sure if this amplifier works just yet. We assume that it's going to work because we have audio on the driver board input pin, but we're not at the end of this yet because we still need to confirm that we have audio on the output terminals with all of the output section oscillating and switching and working, etc. John, damage, Sam, I'm late. So if anyone's recently joined, if you didn't see the live stream yesterday, then I can't really go through what happened in the live stream yesterday, but we had a Hertz amplifier that was just giving us mad headaches, really, really strange faults. The amplifier was developing new faults as we repaired it. What we were doing on today's live stream was grabbing a second identical amplifier that actually had the exact same identical freaking fault, and using that amplifier to repair the one from yesterday that we really struggled with. And so far we have repaired the second amplifier quite easily just by replacing op amps in the preamp circuit, and we possibly have repaired this amplifier by repairing maybe some damaged vias on the bottom of the board here, some kind of corroded or poor solder jointed vias on the bottom of this board. So fingers crossed, guys. What do you reckon is going to happen? Give me an A in the live chat if you think we're going to get audio on the outputs now. Give me a B in the live chat if you think that we're not going to get audio on the outputs. And give me a freaking Z. Give me a Z in the chat if you think that it's going to kill the 074s again. Yo, we got some positivity, guys. I like your enthusiasm. I like your positivity. Most of you guys are saying A. You think that it's gonna have audio. I bloody well hope so. That will be a success. That will be a good opportunity to go crack open a glass of the old vino, I reckon. Although actually it's getting pretty late. How long? I've been streaming for, what is it, 1 hour 49. It's getting on for 11:30. That's okay. That's not so bad. Okay, driver board is soldered in, gentlemen. Driver board is soldered in. Flip the board over. Put the filter circuit back in place. Support the amp, the filter circuit. give our RCA input over here. Okay, so now then is the moment of truth. Now is the moment of truth. What happens? Do we get audio on the outputs? Do we not? So scope screen, we're going to give you 20 volts divide. We're going to first of all zoom in and have a look at the low side drive wave, just to make sure the output section comes to life and starts switching. Should do. We shouldn't have touched or damaged the output section at all. Just want to make sure that it comes on and switches beautifully. So that's the first thing we're going to do. Power the amplifier up and just check for switching on the output section. And this is what the wave shows here is also going to tell us whether we do have audio or not. Because if it starts varying the dead time, then the audio is present. I just want to make sure that we're lined up. I want to absolutely double check every single thing before I power this up. Yes, we're good. We're on master output. That's in the right pins. Don't have any flaky solder anywhere. None of these are bent, nothing's touching, power supply's good. Alright then, here we go, gentlemen. Let's fire her up. We have the same thing that we had a minute ago. We had the same thing we had a minute ago when we try and turn the amplifier on and we just get 3 volts on the board. And that was something to do with this filter board. Like touching some of the vias. So what I'm going to do, I am going to just drop some Tessa tape over the vias on here. So we are full, off, normal phase, gain up a little bit, low, 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 low. Okay, come on, no messing around. Come on, don't mess me around. What is this? What is this? What is this? Maybe it's the board flexing. Look at this, the board is like slightly flexed, okay, because we have this supporting that there. When I try and power it up, I get 3 volts everywhere. Look, 3 volts there. I get on the power supply gate, nothing. So on all of the output section, I get like 3 volts. Why? Why do I get 3 volts everywhere on the output section? That suggests a lack of ground. That suggests a lack of output ground. When you get like the same voltage everywhere on a board. Whoa! Something fucking weird happened there. There's something really not fucking happy about this. Oh, what was that? Okay, so what I just did then is I removed the RCA, and then I just touched my remote pedal. I gave it a little blip, and I removed my remote pedal, but the amplifier continued to power up without my remote signal. Why would you continue to power up without my remote signal? Huh? So maybe there's like dodgy traces on this board then or something, because with the amp at an angle there, so I was obviously supporting the amp here to prevent that coming out. So with this amp being supported, it exhibited strange behavior. So I wonder whether there's some like dodgy soldering, dodgy veer. So now instead we're going to support it from the center of the board, which instead bends this side downwards. Okay. I just want to see it come on, and then we're going to probably reflow everything. Okay, now it's working normally. This is interesting. So now, with the board flexing this way, it works normally. So now what I'm going to do is I'm going to lift up this side of the board slightly to how it was being supported before. And now we're going to see if it makes a difference to how it turns on. Yes, look at that. We have a flex issue. We have a board trace something fucking issue. So by holding the board upwards like this, we get no turn on. When we let the board sink down, and so this side of the board is now weighted down, it now comes on. We have output, and we have fucking awesome. We have signal on the outputs. We have audio. Okay, so gentlemen, we have fixed the amplifier, but we obviously have a strange issue there. Why there's a trace that's bad somewhere, maybe a output ground trace or something. Now where the hell that's going to be, I don't know, but what we can do is we can power the amplifier down, and now like I said, that looks like a ground issue. So when you've got when you apply power to a circuit and you get the same voltage everywhere. If you've ever been repairing amplifiers, and if you've ever accidentally had your power supply ground wire come out of the amplifier without you noticing, if your ground is obviously referenced to the ground of the power supply, when you try and turn the amplifier on or you start probing the board, you'll notice that there's 12 volts everywhere. Not just on the FETs, there's 12 volts on the gate, there's 12 volts on the driver board, there's 12 volts on the output FETs, there's 12 volts on the RCAs, and you're like, oh my god, this amp is fucked. There's 12 volts everywhere. What's going on here? But it turns out the only reason that there's 12 volts everywhere is because your amp doesn't have a ground reference. So as far as the oscilloscope probe is concerned, yes, there is positive 12 volts pressure coming into the amp everywhere because there's no ground. So the fact that when we have the board bended upwards slightly, the fact that we have 3 volts everywhere in the output section, that tells us that there is a ground output, there's an output ground missing, because the amplifier doesn't come on, and there's 3 volts everywhere. So that tells me that it's got to be a ground issue with the output section somewhere. So what I'm going to do is we're just going to drain the rail capacitors of voltage here by using our pull down resistors, turn the power supply off, and now we're going to take our multimeter and we're going to have the amplifier bent in different positions and read the variance in voltage in ground. So with the amplifier in its functioning position, which is this, when the amplifier is like this, it is functioning, right? We want to measure the resistance between the output ground and the main ground. So the output ground is the speaker terminal negative, and the main ground is the battery ground. So on the multimeter here, you can see here we have 1000 ohms, 0.98. If we jump down there. So we have here 980 ohms between output ground and main ground. Now if I move this screwdriver to the top here, so the amp is now bent the other way, do we have the same resistance between output and main ground? Oh, for fuck's sake, we do. Okay. I was hoping that it was going to be output ground. Let's check the RCA ground, actually. Maybe it's something to do with the RCA ground. I also just want to make sure that the amplifier doesn't want to come on, because if it could still be like latched into working mode. So with it in its current position, what do we have? I need to plug the RCA in actually. Otherwise it tries to latch itself on. Okay, no, so the amplifier is in non-working mode. We have just 3 volts sitting on all of the output section here. So, okay, it's missing a ground of some kind in this position. Right. How do I figure out what it's missing? How do I figure out what it's missing? So the board is flexed up here. This is kind of the main area. Maybe I should just reflow everything. Maybe I should just kind of bake and reflow everything that I can see. And that's probably going to be quicker. I reckon reflowing everything is going to be quicker than trying to, you know, figure it out. The only problem is reflowing everything might not solve the problem if it's not a solder joint, if it's like a broken lead or like a bad inductor or something like that. The kind of components that I'm looking out for here are things like this L5. These inductors are very, very fragile to being pulled around. So with the board in its current position, bend like this, I am looking for something that doesn't have continuity any longer. Like, I don't know, here we go, this resistor here, for example. This is like just a fusible resistor, R10E. This is 0 ohms, supposedly. So, you know, maybe that could be bad when bent that way. Maybe this diode over here, for example, D10A, maybe while it's bent up, it's open, but it's not, because we have a decent multimeter reading one way. There, we have a decent multimeter reading one way. We're looking for diodes, we're looking for inductors. We're looking for something that's probably going to show an open connection on the multimeter here. It could also be something in the power supply section as well, because obviously the amplifier's not trying to come on. It's not coming on when we're in this mode of operation here. Let's see. Does it care whether the filter board's there or not? Let's try it with the filter board out. Oh shit! Interesting. So with the filter board out, the amplifier does come on normally when it's in this mode of operation. However, as soon as we put the filter board in, while it's in this kind of bent position here, as soon as we put the filter board in while it's in this slightly bent position, it doesn't want to come on. No, 3 volts again. Let's try backing out the filter board ever so slightly. Now, obviously, one thing to note is we do have lots of like capacitors. See, there's like a capacitor right here that touches this filter board. There's lots of components that actually touch this filter board because it is so tightly packed in here. So what I'm going to do is I'm going to put this filter board back in, and I'm going to put it all the way in. Then I'm just going to back out the pins ever so slightly. So they're still touching, so they're still making a connection, but they're no longer pushing down quite as hard on the main board. So I've just backed the pins out by a couple of millimeters. Here. Now let's see if the amp wants to come on now. Yes, it does. It wants to come on. So it's something. It's obviously something that this filter board is touching. So you see here, amplifier wants to come on. We have current draw, goes all the way up, acts normal. But as soon as I push this all the way down, if I just push this down by a millimeter here, now look. Oh, fuck's sake, amplifier wants to come on again now. It's obviously very, 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 very tight. No, amplifier wants to come on again now. So it's obviously very, very, very tight. Like the whatever it is that's the issue is fucking millimeters away. Millimeters away. So what I'm going to do is, to try and solve this, I'm going to drain the rail caps first. We're going to remove our screwdriver from underneath. Going to remove the filter board. We are going to just look for any signs of... Going to look for any kind of signs of rubbing or anything on the filter board. Now, obviously, this filter board has had some capacitors which have been soldered in as an afterthought at the factory. Now, they might not clear something on the board down here, Looks like they do. Looks like they do clear that stuff. So that's probably not the issue here. So we want to see, is there anything else that doesn't potentially clear this filter board here? We're looking for stuff that doesn't clear it, maybe. Maybe signs of rubbing on here, something touching. Not really seeing any obvious signs just yet. A solution might be to kind of cover all of this stuff in Tessa tape. So let's start by covering those capacitors, which are obviously an afterthought. Let's put some Tessa tape around those, just in case they're touching the op amp over here. Start with that. What are people saying in the live chat? Let's have a look at your suggestions right here. Twist the filter board around to see if you get an intermittent connection on the ports. Yeah, we could do that. Probe things with your toothbrush again, Sam. Oh, yeah, with the back end of the toothbrush, so it's not conductive, yeah. Do the posts hold the board off slightly in normal operation? No, it's properly pushed all the way down as far as it will go. Because this screws down into the board, so it is all the way down as far as it will go in normal operation. Let's cover some more stuff in Tessa tape here. Let's get some more Tessa tape on the go. Covering as many kind of things I can see in Tessa tape that might protrude, might touch, might rub. Okay. Check for bad solder joints on these pins. See if any of them are wobbly. They all look pretty solid, to be honest. Okay, so now that the amplifier is, now that we've kind of fixed the the amplifier works, we know that, but it has this intermittent issue. So let's plop this back in then, and let's try and get the issue to be intermittent. While it's trying to power up, let's see if we can get it to be intermittent by moving it around. The thing that I don't want to do though is I don't want to kind of be whatever is shorting or disconnecting while it's trying to power up. I don't want the output section, I don't want the MOSFETs to be switching while that's happening. Dude, Behan Beats 843, cheers for the 5, man. Keep it up. Thank you very much. That's a super sticker. Thank you very much. That's pretty awesome. So what I don't want to do is I don't want the output fetch to be switching while we are inducing this issue. You see what I'm saying? So I want to... There's like a noise there. What I want to do is I want to disable the output section so that it doesn't try and switch while we're moving it round. But what I can do instead, rather than having to try and disable the output section, is I can turn my power supply onto a very, very low current. So if I turn my power supply onto a very low current, we've got, at the moment going in, we've got 10 volts and we're letting 1 amp in. If I turn that all the way down to 0.8 of an amp, okay, what that'll do is it will turn the amplifier on so slowly that we can hold the remote on and wiggle it round without the amplifier ever building enough rail voltage to actually turn on. And to monitor that, we're going to take a second probe of our oscilloscope here. Take a second probe, and we're going to put the second probe on the rail voltage here, just to monitor the rail voltage to make sure it doesn't get too high while we're doing this. So the amplifier definitely isn't like trying to come on. So we get 10 volts on there. Yep. 20, 10, 5. So now then, with the filter board in, we're gonna sort of like apply some power to this. I'm gonna support the board by this cable, and I'm gonna gently sort of wiggle it around and see whether now that we've covered half of this in Tessa tape, I'm gonna wiggle this around and see whether the amplifier starts or stops trying to power up. In order to do that as well, I'm probably gonna want another oscilloscope clip on the end of this one. Does that one fit? Does that fit? No, it doesn't quite fit on there. Where's my normal clip for this one? Maybe it's in here. Let's try this one. Nope, not quite right. Maybe it's this one. There we go, that'll do. So I'm going to place this one on the low side drain. That's where we were getting the 3 volts before. So now we've got our oscilloscope probes hooked up. We are ready to test. Okay. So we currently have some rail voltage, I believe. Yep, we currently got negative 9 volts in the rails. Okay, that's fine. So let's hit the remote and let's see what we have while I'm giving it a wiggle. Okay, so rail voltage is building in that position. Let's flex it up. Okay, there's the issue. There, so I just flexed it up. I just flexed the board up ever so slightly, and with it flexed up, it definitely did have the problem. So there is an issue here still. It is on the main board. The issue is on the main board, not necessarily on that filter board. So if we flex it up like this, you see how on the scope everything bounces to +3. Yeah, with the board held in this position, flexing in a U shape like that, everything bumps up by like 3 volts. Whatever. Whereas if I now hold the board like this, the amplifier will come on normally by building rail voltage. So now that we have confirmed that it doesn't seem to be anything shorting out on this filter board, we need to go searching for. We need to go and reflow. We need to go reflow, guys. We need to go reflow as much stuff as we can find on this amplifier board. This is going to be a pain in the ass. This is going to be a pain in the ass. So we know that the amplifier doesn't work when it's held up in this way. So that means that a connection is being broken like this. So we're most likely going to see the broken connection on the bottom of the board if we flex it up this way perhaps. It could be a via, could be a trace. But it might just be it might just be something that we just don't see. I'm keeping my eye out for traces and pads over here. This is going to be such a needle in a haystack. Such a needle in a haystack to find. Guys, what would you do? Would you reflow everything that you can see as a starting point? Or would you, I don't know, would you start looking for... That noise is just this wire touching this capacitor, that's fine. $20 to life says buy a new amp because it's beyond me to fix. Yep, I'm with you. the question is, what? So it definitely must be a ground, something. So with the amplifier in that position, with the filter board in, we're not getting, the amplifier doesn't want to come on. We get 3 volts everywhere in the output section, which is obviously something to do with like the RCA input. Sorry, the remote input. When we remove the output RCA, when we remove the RCA input from here, with the board in the bad position, the amplifier comes on and latches. Even after we remove the remote, the amplifier stays on. Such a weird fault. Such a freaking weird fault. Start at the repaired area and see if it goes in the area where you're flexing the board. Like, if this was a computer motherboard or something small with like without big components on it, I would throw this into my oven. I'd put it in the oven at about 250, 300 degrees Celsius, which would reflow everything all at once. However, this has got relays, big capacitors, it's got wire on it, it's got RCA plastic shit on it. So I can't just drop this in the oven without removing like a fuck ton of stuff off of the board. Check continuity on each trace as you flex the board. Dude, there's like 1,020 million traces on here. How do I check the continuity of every trace while flexing the board? If I had 4 arms, maybe. It's something really major. It's a major trace. If it's not a ground trace, it's a major trace. It is something like a ground trace that disappears. I'm going to put the board back in its faulty position. I'm going to shove this back in the board. The weird thing is, without the filter board in place, it does actually come on. It comes on normally, even flexed in this position. It's not making any sense, is it? Let's have a play a bit more with the filter board. So with the filter board in, I've just backed it out a touch again. So it comes on normally like this now. So what I want to know actually, so I've backed out the filter board just a touch. So with the filter board all the way in, okay, it doesn't come on. It has the weird issue. Okay, so with the filter board backed out ever so slightly, the amp does come on. So maybe it's something that actually pushes down. Maybe it's something that the filter board pushes on. So what I'm going to do is, I think maybe the first port of call is to maybe reflow a bunch of the components that the filter board pushes on. You see? So the filter board pushes on a bunch of components when it's all the way in, right? And when it's not all the way in, it releases pressure from the components that it touches. So, for example, this transistor, this A13B1E, I know what to do. I know what to do. Let's try powering the board up, and let's start putting pressure on every component that the filter board touches and see if it changes the amplifier's working operation or not. So watch the scope screen in the top corner. So at the moment, the amplifier wants to come on normally, so we don't have any bumping lines. So what we're looking for is we're looking for a bumping line. So no bumping line at the moment. Let's touch this A13B1. Okay, no bumping line. Let's touch these capacitors. No bumping line. This transistor here, no bumping line. This capacitor, this transistor. Nope, nothing so far. Oh, for fuck's sakes. I was really hoping that that was going to be the thing. It was like a physical thing where the where the filter board is like pushing down on something. Is it, what else does it touch? Does it touch something else that I'm not aware of? Back in all the way. Okay, back in all the way. Now we have the pulsing. So let's try each side. So I'm going to just lift this side out ever so slightly. Still the issue. Push that back in. Let's lift this side out ever so slightly. Still pulsing. Okay, let's lift this side out a little bit more. Okay, now it comes on normally. So that side lifted out a lot, comes on normally. This side lifted out quite a lot. Pulsing. Comes on normally. Oh, for fuck's sake. So it's both sides. How can this be? So the pulsing means that it's not coming on properly. Pulsing's gone. Pulsing's back. So okay, it's not a pressure. It's not a pressure on the board. It is an electrical thing. Right. Okay. Okay. So next thing then is to have a look and see whether there is any issues with ground on here compared to when it's flexed the other way around. So let's put it back in its normal operating position, which is like this. Okay, so now it's in its normal operating position where it works. Yep, works normally now. And now if I flex it up slightly, now it doesn't. Works, doesn't, works, doesn't, works, doesn't. So with it in its working position, let's see which pins are ground on here. We have this pin is hang on a minute, let's go. So that pin is output ground. Okay, that pin is main ground. Okay, so we have continuity then. So we have main ground over here. And over here we have output ground. Main ground, output ground. So what about on this side? That is output ground. So now let's put it in its non-functional position and let's see if anything changes about that. There we have main ground. And we have output ground. Ah, hang on a minute. No. Main ground. Output ground. That's normal. This side. Yep. just reflow solder on all pins. That's probably what we're going to go for next. Mike Honda said, flip over the board, check the main board where the dials rest. Might be an issue there. Yep, alright, let's flip the board over. So you can see but the dials come through the board slightly. So let's have a look. Let's flip her over. Shit, soldering iron was fucking left on. Flip the board over. Okay, here we go. Here is where the dials come through the board here. So we've got a switch there, switch there. Now these ones are coming through the board, and we have, is that one touching the board there? Let's have a look. We have a via there. Doesn't look like there's any issues. Just out of interest though, I guess what we could do is we could just put a little bit of Tessa tape over the case of this one, which looks like it was touching the board a little bit at the edge there, and also across the pins. That was the only one that seemed to be, you know, maybe kind of near to touching anything or whatever. Chris, generous application of hammer. No, we've come too far with this board now, guys. We've come too far with this now. We can't hammer it. We're too close to el finito. Oh fuck! Oh no, I thought that had fixed it then. Well, it's actually helped. It's actually potentially helped. Whether it has helped or whether it's just from handling it, but now with the screwdriver in this position, right, which it has been for a while now, the amplifier does come on like normal. But if we bend it up further past that point, it does still have the issue. So the issue is still there, but it seems to be maybe less intense now. Maybe it's just I haven't pushed this down fully. Okay. So I think that maybe we're at the point where we could be safe to put this back in the case, because obviously in the case it's flat, right? So I don't know. Maybe we should Tessa tape around all of this. What do you reckon, guys? Should we just Tessa tape around all of these potentiometers here? Yeah, it probably will work fine when mounted with screws. So obviously when it's in the case, it's not bent up at an angle like it is now. But I'm just not happy because it shouldn't be doing that still. You know, regardless of whether you've got the board flexed up at a tiny angle, it shouldn't do that. That does show that there is a slightly poor connection somewhere. Which we could just put it back in the case and ignore it. But I am quite thorough and if I see something I don't like, I try fix. Michael C is convinced that there is a cracked solder joint, trace, or pin. I believe so as well. I believe that is more likely the case as well. I think it might just be a coincidence that putting the tester tape on that potentiometer just kind of like made the issue less apparent. But I'm doing this anyway for shits and giggles. Okay, that's the 4 main ones that stick up. So let's just see. Has it made any difference? Again. How much is a replacement board for this amp? They don't sell replacement board for this amp. It's old now. Okay, so that's in place. And let's see. So, yep, she comes on like normal, but if I hold it up slightly. Oh, okay, that is working. Yep, that's working good now. Yep, the amplifier comes on normally, even when held up like this and even when bounced. Fuck, so maybe something was just touching against one of those potentiometers. So I would like to thank Mike Honda for that suggestion, actually, because he suggested to look over on the other side of the board, which kind of made me look at the potentiometers there and just be like, that's a little bit close, possibly. So now then, guys, the next thing to do is to put it back in the case. We want to put it back in the case. We want to put a few screws in the board. And with a few screws in the board, we want to double check that it is still fully operational as it is now. So basically, I can't test the screen. Dev null, I can't test the screen because we are still waiting for a 74HC959, which I will need to order. But what we can do, actually, just before we put it in the board, thanks for that reminder, what we will do is I will suck all of the holes from the pads for that. I'll suck all the holes from the holes from the pads so that we're ready to drop a new chip in straight away and solder it in from top board when it's all in. Try and grab a toothbrush if I can as well, just to kind of dust off the underside of the board of any little solder balls or anything. There we go. Okay, where's the case? The case is down here. Yep. And don't brush your teeth after this. Great advice there from my man 25 Hertz. Listen to my man 25 Hertz. Don't brush your teeth after doing this. Slowly does it. Slowly does it. Now push that wire down so it doesn't get caught, like it obviously has in the past at some point. Then tuck it up around here. Get it into that gap. There we go. Pull her back. Okay. So, reassembly time now then. I'm not going to do the full reassembly of this because it was quite boring to watch a reassembly of an amplifier. But what I'm going to do is put enough parts back in that you can see that, you know, this works fine now. And also what we want to do is we want to run this amplifier for a few minutes and make sure that these TL074s don't kill themselves like they were before. Maybe I did just have a bad batch of those ones. These ones don't seem to have been killing themselves. We have powered the amplifier on and off a few times since, but they don't seem to have been killing themselves like they were. So we're just going to put enough of the stuff in here now to confirm operation. And what I want to do then is I want to idle this amplifier. I want to run this amplifier for about 5 or 10 minutes while I answer some Q&A. Actually, do you know what's quite funny? I think that these headers, I think that these riser bolts actually hold the driver board up a bit higher than than we were pushing it down. So I imagine that it was probably fine, and we did all of that nonsense for nothing. There was actually, I give credit to somebody in the live chat. Somebody in the live chat said that they betted that when it was all screwed in, it was going to be fine. And I probably need to give credit to that person, because it does seem that with these bolt risers in place, they do hold it up a touch higher than we were pushing it in. So I imagine that it was probably going to be fine when we put it back in the case anyway. Yes, Matt. I'm pretty sure that was Matt. Give yourself a round of applause, Matt. I'm pretty sure that you were bang on the money there. Okay. Now, very important, gentlemen, when you are reassembling an amplifier, absolutely critical that you make sure that no bits of metal or solder have found their way behind the MOSFETs or onto the thermal paste or the pads or anything like that that may short out to the case when you put these back down. So there's actually something a little bit there. There's possibly a tiny little bit of metal just there. So that was what I'm looking out for. That stuff just fucking gets into this, especially this yellow stuff. You're looking for any kind of dots or point or like little dots on the yellow. You're looking for any tiny, even if it's not metal, even if it's like plastic or a bit of dust. It will prevent decent thermal contact being made between the FET and the heatsink. So you just want as flat as possible, definitely no bits of metal or solder, because that's going to give you a bad day. It's going to cause the FET to short against the heatsink. So make sure that there's nothing in between your FET back and your case there. Now, interestingly, somebody in the past here has put thermal pads on the back of the rectifiers. Now, why don't we need to do that? That is because, gentlemen, the rectifiers here are actually already insulated. They have insulated backs on them already, so you don't need a thermal pad between the rectifiers and the heatsink. By doing so, all you do is you just limit the thermal transfer slightly. You might as well, you just want them straight to the heatsink for maximum thermal transfer. So we're just going to remove that, move the thermal pad over to this power supply MOSFET here. There we go. And then we just want these straight direct to the heatsink. Although, you know what, maybe the pad actually does help. Maybe the pad actually fills in the gaps. Oh, screw it. Let's keep the pad in there. It was working fine before. Screw it. Let's keep the pad in there. I still like my cracked trace and pins theory. I mean, you could still be right. You could still be right. Ba-dum, ba-dum, ba-bum. Now, for testing, for endurance testing, I'm going to run it for a few minutes while I'm answering some Q&A in the live chat. While it's running, I just want the output MOSFETs clamped to the heatsink because I don't want them heating up or anything like that. Because I'm going to be driving a small load, small speaker. So I just want to get these. Apologies for the loud banging. Just want to get these clamped into the heatsink here real quick, just to keep them nice and cool while we're running. There we go. And the other side. Guys, don't let these get bent. If you are using, especially these silver ones, okay, now these bend pretty easily, and this one actually I'm looking at now, I'm just looking at it down with one eye. This one is ever so slightly warped. So when you're putting these back on, if you've got any slight inkling that they might be warped, what you want to do is put it on just a touch like this. When you hammer it on, okay, if it's slightly warped, then it might not actually be putting pressure on one of the MOSFETs on one side. So you just want to double check, never assume that it is actually pressurizing the MOSFET against the heatsink. Always just take your eye and just look down through some of the gaps between the MOSFET and the heatsink and just press on it like this. And if you see the MOSFET move even a micromillimeter, if you see the MOSFET move as you apply pressure, then it's not holding it on there tight enough and there's not good enough thermal transfer. So you need to replace that clamp if that's the case. I don't trust these metal ones. These metal ones definitely are not as good and sturdy as the black ones that you get in the Korean amplifiers. Black ones are a bitch to take off, but as a result of that, they are very, very sturdy. They're more brittle, which is good. They don't bend. They will hold their shape, and then once they get stressed too far, they'll just shatter, which is better than bending like this. Okay, so that's all the MOSFET clamps on, and I think that might be just about enough things in the board for me to be happy to run this and test it out fully for you. Leave it running while I'm answering some Q&A questions. So what I'm going to do is hook up my small test speaker, which is this little 6-inch JBL, which has been given a shit ton of abuse in the workshop over the last couple of years. Let's put that down on some fabric to stop it from bouncing around. What we got? Something fabric-y. There we go, this towel will do, this jank looking towel. Shove that on there. I'm going to plug that into the speaker terminals, flip her over. And just for good measure, let's put our knobs back on. Now one of these is on the floor somewhere, so I'll pick that up later. 50 Hertz boost down there. Okay, cool. Now, RCAs. RCA goes in. Gain goes down. 50 Hertz goes in. Power leads go in, and we're gonna lock. Let's grab the remote cable here. Remote cable goes in. Let's lock the remote cable in place, because if that comes out, that's going to scare me into thinking the amplifier's like turned itself off or gone into protect or something. So let's get the get a very small Allen key. The speaker terminals actually on these are really crappy. Look how tiny these Allen keys are. Look how tiny these terminals are. They're so small for a 2.5K amplifier. I definitely would have used bigger on this amplifier here. One last thing that we're going to do is we're going to screw in the case ground wire. Now the importance of that is it will prevent like lots of noise. The case ground often has like lots of switching noise on it, which can cause problems in the long run. So we're going to apply the case ground wire, and that's going to ground any noise from the case going anywhere into the rest of the circuit, for example. Power wires going in now. Okay, excellent stuff. Let's take our let's take our oscilloscope probes, and I'm going to hook one of the oscilloscope probes onto the negative rail. So I'm going to take channel 2 of the oscilloscope, hook that onto negative rail just so we can monitor the rail or monitor the something like that, the switching. And we're going to take this one. Now I've got a few places I can hook this. I can hook this onto the RCA signal, like onto one of these resistors over here that we were looking at before, just to make sure that no DC starts leaking onto there. I can do that. That might be a cool idea. But also I don't want my oscilloscope to kind of influence any of that circuit badly, so maybe I should put this one on the on the low side drain, perhaps something like that. Maybe over here. Let's see. Where does low side drain connect to? Low side drain goes into the inductor here. So one of these bad boys, one of these resistors, we can go in there. That'll do. Okay, so we have low side switching on the oscilloscope, and we have rail voltage on the oscilloscope as well, 20 volts. Let's go to high frequency switching mode, turn the current up on the power supply. We've got 10, let's give it 11 volts now that we're actually powering it up. Let's give it 5 amps. We're driving a little speaker now. It's only a very, very small speaker, so it doesn't require much current. Let's start off with the gain down super, super low. And actually, just the last thing to check before we power it up, just make sure you don't have any case ground shorts. So we checked for little metal shards, but always double check. So take your multimeter, put one probe into a case ground position. Just check all of the pins which are connected to the case. So low side drain over here, low side drain over here. And on this side, and check the power supply. Yup, and just check these little voltage regulators over here as well. Make sure none of these are shorted to the case ground. Okay, I think we are good. Always worth double checking that. The amount of times that I have gone, oh yeah, I should just check that before I powered up, and I found a case ground short. It's so easy to happen. It happens so often. The tiniest bit of metal that you cannot even see with your eyes can get in between the FET and the case ground there. Always check it with your multimeter before you power the amplifier up. Worth doing every time. Whew. Okay, let's go. Let's power her up. See what happens. Okay, switching is enabled. The speaker is moving. There we go. Okay, so what I want to do is I want to leave that running for a bit while we answer some live chat questions. So I have the amplifier hooked up. We're running at 10.9 volts. I'm just going to actually increase that a little bit to 12 volts now. It should be happy running at 12 volts, of course. Whoa, something fucking happened there. What happened there? It just went, the speaker just went like boom. Maybe one of the op amps died again. Like I heard a funky sound through the speaker that just kind of went boom. I want to check for DC offset on that op amp. I didn't like the sound of that. I didn't like the sound of that. So probe 3 now is checking for DC on the signal line. Hang on a minute, let me just zoom right out. Okay, that's with the amplifier off. That's potentially normal. Let's turn the gain down a touch. Let's crank the amplifier back on. 10.4 volts. Okay, yep, no DC there. So why did the amplifier go boom? Let's crank the voltage up a touch. Oh, I think it's my power supply. When my power supply switches between like 11 volts and 12 volts, it enables a relay that switches to a new circuit. Oh, no, no, no. Oh, the speaker's doing all kinds of weird DC shit. Oh, no, 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 no. What the fuck? Okay, let's back off the voltage down from 12 volts. Still doing all kinds of weird DC shit. What's going on here then? For fuck's sake. What's going on here? Okay, let's remove the RCA signal. Let's remove the RCA signal and let's see if it's still doing that kind of weird DC shit on the speaker terminals. No, no, the gain's not at full. The gain is down low. Whoa! Fuck's sake, something is not right with this. What the fuck? I still think we have... So that was with no RCAs. No RCAs in the amp. Okay, I'm just going to disconnect the speaker real quick, okay? Because I don't want to send like full rail voltage to this speaker, which could potentially happen here. So I'm disconnecting the speaker. Now what I'm going to do is change my oscilloscope probe. We're going to have a look at what we have on the speaker terminal, which is going to be just over here, positive speaker terminal. We're going to be looking for DC, strange DC-ness on the PWM as well. Ooh, yeah. Yeah, there is some kind of oscillating DC. See how it's all kind of jittering around a little bit there? Now I don't know, lol, what the fuck? Yeah. It's moving around all over the place. Now is that from the signal? Is that coming in from the signal line? Or is that part of the drive circuit that's doing that? I don't think it was doing that before, was it? Is it to do with the maybe it's to do with this level shifter being removed, because remember the level shifter did actually disable the output drivers when it was bad. So I'm going to probe around with the I'm going to see whether there's the same kind of shifting on the preamp section here, on the signal line. So the signal line is the output of this 072C is the output of the signal line, right? So if I zoom right in on that, get nice and close in on that. Yes, it is. We do have that fluctuation on the signal line. You see this signal line, this middle signal line that I've got. This is fluctuating up and down a little bit, and it's causing this noise, this kind of noise on the outputs here. Is that, now where is that coming from though? Ooh. Uh-oh. Yep, guys, we have dead 074s again. Look, here, this is what I have on the 074s. I have like 3-4 volts of DC. So the amplifier works, but it's still killing 074Cs. It's still killing 074Cs. Wow. Well, Which one's gone bad this time? Front or back? I think it's I think, is it this front one? Yeah, this front one's that's got negative 10 volts. That's fine. This side, yeah, I think it's this front one. It looks like it might be both of them. Both of them have DC where it shouldn't be. But I think it's this front one here. Wow. That fucking sucks, doesn't it? Now we seem to have reached equilibrium. So, yes, these 074Cs have died, have shorted. We have 10 volts on one of the outputs of the but now it seems to be in equilibrium. What do we have now on this? We have negative 9 volts on the RCA line. So what happens if I feed it now with some RCA signal? What do we get on the speaker terminal when the amplifier turns on? So these op amps have now fully shorted. They've fully leaked. They've gone fully leaking. We've got like 10 volts on the outputs again. So what do we have on the speaker terminal now? Do we get a nice big bump? Oh, a huge bump. Yeah, that's the DC. When the audio activates, that is a huge bump. 20 volts. Let's see what that looks like on the scope screen. So when the amplifier comes on now, we get this huge bump. Watch. Boom! Big bump all the way, almost up to top rail. That's because there's heavy DC on the signal line. Do you use lead-free or traditional solder? I much prefer 60-40, 40-60. I much prefer the proper leaded solder. It's so much better. The 074s may have died when the 3 volts was everywhere. It's possible. So then, guys, last thing this evening. The last thing we're going to do this evening is we're going to remove the 074s one more time. We're going to put in 2 more one more time, and we're going to see if they last or not. So, where is my tweezers I was using to remove those before? I'm just looking for, I dropped a 074 earlier from the donor board. I just want to see if I can find it. Oh, there's my other knob, that's good. Oh, well, I found it. I found the one that I dropped, but I've obviously stepped on it a few times because it is now completely flattened. So two new donors then. Let me just go and grab 2 new donors, and that's the last thing we'll do. I'll answer some questions and then see if they die, and then we'll hit the sack. I don't think I've got any things other than 074s. You know what, actually, you know what I'm going to do is I'm going to play with the one that we fixed earlier. The one we fixed earlier that also had dead 074s. I'm gonna play that one instead. Thanks for the 5 also. Sorry, Elliot, thank you very much for the 5. I didn't acknowledge that. I was too pissed off by this. Thank you very much, my man. Massively appreciate that. I'm going to play the one that we fixed earlier that didn't have quite as many problems, but it did have dead 074s. So I'm just curious to see whether that one survives. If that one kills the 074s as well, then we know that 074, just for whatever reason, maybe it's the right part for this amplifier. So let's put this one down to one side. Now let's grab the other Hertz. If I can remember where I put it. Where did I put the other one? That's the one we just worked on. That's another box. That's not it. Where did I put the Hertz that we worked on earlier? Oh, here. Here it is. Okay, so let's grab this one. Now let's test this one out while we're doing live chat, and then that will tell us a bit more about why the other one's killing 074s. Remote goes in, connect our speaker, speaker goes in, okay, yeah. RCA goes in, pre-in, gain down low, off, full, off, 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 upper touch, remote wire, okay, hat cam. I think that's everything. Power supply on, 10 volts, 5.1 amps. Now remember this one actually has the slightly, actually I'm going to put the clamps back on this one. This one has the slightly dodgy looking drive wave on the output FETs, but I think that's just because the gate resistor values may be not quite right. I'm going to leave those off just for now. Actually, I don't know. Maybe I should put those on. Actually, I'll leave them off for now. I'll see how hot they get. Thermal imaging camera just to keep an eye on the temperatures while we're running it with the clamps off. Something very annoying is happening with my thermal emission camera. For some reason, it doesn't hold its settings anymore. So every time I turn it on, the brightness is at 10%. I've got to turn it up to 100. And then I've got to go in, I've got to put it on this mode, turn that on. And then I've got to go and change the screen to how I want it. It doesn't remember the settings anymore. Maybe the internal battery's dead. Someone suggested internal battery, so I'll have a look at that. Okay. Let's turn her on. .12 volts on the power supply, and let's monitor the heat from the output FETs as we go. Okay, so we've not got any funny DC on the speaker just yet, which is good. So that's cool. Let's put the clamps on. I think I'm going to put the clamps on the output FETs because they are just kind of warming up a little bit idle there. See where we've got our positive and negative rail voltages. Sync that down before we put the clamps on. There we go. I don't really need to put them on the power supply FETs just yet. Power supply FETs won't get as hot in this scenario here. I'm going to put the output section clamps on, and I'm also going to put the clamps for the voltage regulators because they will heat up just doing nothing because they're dropping voltage across them. There we go. Michael C, what's up, buddy? Okay, cool. So we have sine wave on the output of this one. So guys, while we do some live chat, then let's hold this on here and let's do some live chat. We're going to monitor what the output of this one looks like to make sure that nothing bad happens to it. Make sure that the TL074Cs don't die. Okay. A year ago, you were repairing an MTX 4000 watt. I never did see part 2 of the video. Interested in seeing the second part because I got an MTX. If there's not a part 2 of the video on YouTube, I probably don't have a part 2 of the video. But I did fix it. I did fix a couple of those. They are. That's right. The one that I repaired on YouTube was an absolute dead one. It was absolutely completely burned to the ground. I think I did do a part 2 video actually. I'm pretty sure we got it up and running on video, but it might not be called the same thing. It might be called something else. So have a look at the next few videos after that one. Still looking good. Well, suggesting a new project once this amp is done, that's all. Oh, okay, well this amp is, once this amp is done, I'm going to bed. It's 1 o'clock in the morning now. How about you go to the 074C and check the pins you were having the fault on and see where they go? Yeah, we could do, but the thing is that it doesn't matter where they go. The TL074s are leaking voltage internally through them. There is nothing strange or untoward on the 074Cs when they're not leaking. There's like, you know, just ground on all of those. So Sam, did you ever start that video on the upgrade for Big D? Yes, absolutely, James. I have about an hour and a half worth of footage on that video. So it's getting there. I just have some work to do on the transformer. So the audio pipe 3K is currently in modification at the moment as we speak, and it's I'm just doing some work on the transformer. Reese Carney, something's on its way to you. You should have it Sunday. What's on its way to me? Let me know, Reese. What are you sending? Sam, thoughts on a Soundstream reference to 620.2? Not too sure. Haven't seen that board personally myself. Don't really get a lot of Soundstream over in the UK. Not much of that stuff is kind of brought over from the US. Best budget amp under 250. I don't really know the US market. I'm sorry, man. Best budget amp under 250 here in the UK is the Taramp Smart 3. That is an amazing amplifier. 3000 watts at 12 volts at 1 and 2 ohms for under £300. You can't go wrong. It is such a clever little circuit design. Really, really well built amplifier. Really, really well designed amplifier. The Smart 3 is freaking awesome. Bevids, if you have amplifier boards that are not useful, can I buy one off you to learn and put it on my wall? Where are you based though? Because if you're not in the UK, the cost of shipping a dead amplifier board is going to be like over $100. So it's not worth it. You're better off like hitting up some local car audio groups on Facebook and asking anyone if they've got any dead amplifiers. Why are there caps soldered to the pins of a couple of chips in there? Capacitors soldered to pins of chips are just to help with noise isolation, maybe get rid of some kind of ringing on that data line, for example. Nothing, you know, nothing too major, not really an issue as such. Is it true they don't hold long on low frequency? No, that's absolute nonsense. They're absolutely fine for all frequencies. The thing that's different about them is because they're full range amplifiers, they play up higher than most Korean amplifiers. So it sounds like their lower bass is less prominent than their higher bass, because as frequency gets higher, your perception of how loud it is gets louder. So 140 dBs of 25 Hertz sounds really quiet compared to 140 dBs of 50 Hertz, for example. So because of the way that these amps are full range, they do let more of the higher bass through, which means that in your head it sounds like there's less low bass, but there's not. In order to get the Taramps to sound like a Korean amplifier, you just need to turn the low pass right down to 0 on the amplifier, and you need to make sure that your low pass is set very, very low on your head unit, for example. This amplifier is going great. This amplifier is going great. I don't think we've got any DC on the op amp so far. So, okay, that's good. What I'm going to do now then is I'm going to turn the voltage up from 11.8 to, going to crank it up a touch. Going to go up to 13. Going to go up to 13. It's actually a very good point that we might have been killing those 074s when we were putting the filter board in and pushing it all the way down. It's very possible that we were doing that. I can't remember. I don't think any of the TL074Cs, I'll have to check back through the video. I don't remember if any of them were dying when the filter board was removed. So it's possible that we were killing them by having the filter board touching something that it wasn't supposed to be touching. So maybe I should replace them one more time. I can't seem to find any 074s though over here to replace it with. But now it's in the case. Although no, actually, because when they were dying first time round, when the 074Cs were dying first time round, when we first ever looked at the amplifier, we hadn't removed the filter board yet, and the headers were still in place, weren't they? So that can't be the case. There must be something that's killing them. Can't wait for the Smart 5K. Yes, I agree. The Smart 5K, and I think they're doing an 8K, is going to be freaking awesome. Good replacement for IRF Z40. I think those are power supply FETs. So in that case, you should use the IRF 3205. Sam, once you told JL Audio JX 1000/1D is very efficient. Do you remember how much it was? I think it was like 79% at 1 ohm. No, hang on, the JX series. I think the JX series was about 76 at 1 ohm, which is okay. It's not like crazy mad efficient. It's just okay. Te amo Mika, I'm in the UK. I can come and collect. Yeah, I mean, to be honest, most of the old donor boards that I have are like, there's no point trying to fix them. The reason that I have them as donor boards are because there's no, like, they're dead to the point where, like, there's no point trying to fix them. So really, I don't really have anything that I could give you to learn on, really, that would be worth you learning on. Like, everything that I've got is just super crazy faults that, you know, or like burned boards that there's no point trying to fix or something like that. I find my Taramps MD5K, there was a roll-off at lower frequency. That's because there possibly is a fixed high-pass filter, fixed subsonic. You can bypass that. You can bypass that on the circuit and it will sound great. Yeah, this little speaker sounds good. We haven't got any DC yet. I don't think these op amps are killed. So let's just see what's the operational temperature of these op amps. Look, see, the fucking screen has gone dark again. I've got to change the settings all over again. We don't get SCAR in the UK, so no, I haven't seen any SCAR amps. Not something that we get over here. So these op amps are currently running at about 30. What do we got? 33 degrees. So yeah, after like quite a few minutes of operation, we're at 33 degrees on those op amps. Let's crank the power supply up to 14 volts, make sure that works fine. I hate going this high. I hate 14 volts. It's such a ridiculous amount of rail voltage and stuff. It's just stressful. Whoa, something fucking crazy happened there. I moved my scope probe and something weird happened. But I noticed my scope probe was just over the driver board. Hang on a minute, let me just crank that back down. Oh, shit. Oh, no. Guys, the 074s just died. We have DC on the 074s now. Now, is that a coincidence? When that happened, my oscilloscope probe the wire was just here. what I did is I moved my wire. I just moved it like that. It's just a rubber wire. I just moved my wire like that. But as I did that, the 074s died. I think that's a coincidence. I think that they died when I turned it up to 14 volts. Because we now have 9 volts on the signal here, on this pin right here. So you know what? I think that 074C just isn't right for these amplifiers. Maybe it just needs something else. Yeah, that's the big bump as the DC causes a problem. So let's I'm just curious to see actually what happens. What does the audio wave look like now? Now that the 074 has died, what does our audio wave look like now? Okay, interesting. So our audio wave actually still looks okay. Maybe. Let's have a look. What does our audio wave look like? Oh no, it doesn't. It looks like a fucking janky shape. Look at the shape of that. It's all over the place. It's like sharp on the down and big on the up. No, okay. So maybe 074C isn't the right part for this amplifier, and maybe these were just replaced with 074C and they're not the correct part. So what I might have to try and do, does anybody have one of these amplifiers? Somebody said on the stream that they had one of these amplifiers in pieces. Can you just tell me what parts do you have in that location there? Do you have 074Cs? What do you have? Because both of these amps are killing the 074Cs, so they can't both have the same problem. What's up, Daniel? Daniel Doria, how's it going, man? Hi, Sam, living in Iran, best country in Asia. Awesome. Actually, one of my best friends is from Iran, actually. Him and his mum. Well, him and his mum. His mum's from Iran, and his dad is from the UK. But my friend Michael Habib Hughes is very Iranian. He's fucking hilarious. Lovely guy. Seems like too much voltage is frying the op amps. Voltage regulators possibly overheating. I don't know, I don't think so, you know. What I need one of these that hasn't been abused by whatever technician, whatever place looked at these before. Wherever these came from, I just want to grab another one of these in and just take a look at whether they're using 074SN. I just want to see whether they're using 074CN and I want to see what voltage is on the VCC plus minus. The thing is, like, it can't be too much voltage that's killing them because they can take way more VCC voltage than that. Look, let's have a look at the data sheet for these. TL074CN. Right, the plus minus VCC voltage of these. Oh, what the fuck? That should have taken me to a There we go. TL074. VCC plus, VCC minus. Parameters. Here we go. Supply voltage. we have got plus minus 18 volts. Okay, so on this amplifier, we have plus minus 12 volts, which is way under the plus minus 18. TL074, here we go. So where does it tell us our voltages and stuff like that? Supply voltage, Vs equals VCC minus VCC. Actually, you know what, the max is 42. So yeah, plus minus, I don't know, what's that? Plus minus 20, like plus minus 20 volts. And we've got plus minus 10. Absolute maximum ratings for TL07XH. All devices except 07. TL07, yeah. Reese Carney sending pic in Messenger now. Oh, nice. Reese Carney coming through with the goods. Reese has just sent me a picture of what parts are actually in this Hertz from stock. And lo and fucking behold, it is actually a TL074C. Why? So they are the original parts. They're the original parts, but I have two amplifiers here killing them. What the fuck? I don't understand. .9 volts and 11.98. Let's crank her up to 14 where she died. 11.9, 11.98. The thing is it like counterfeit chips, yeah, maybe, but I've tried two different batches. I've tried ones that I had that were brand new, and I've also tried ones from a donor board that were going to be legit. They're from a factory. They're going to be legit. No idea. I don't know why it's killing them. Both of these amplifiers. Alright, well, either way, I think we're going to lock off the stream this evening. So, like, the amplifiers work, but they're killing the 074Cs. So, what I might try is I might try and order some more resilient, more robust parts. The 074 is not very strong, resilient, robust. So, I might try and order some better parts that are more resilient to, you know, ESD and stuff like that, and see how they survive. Does the screen still work? Actually, that's a point. That's a question that I want to ask myself. Does the screen still work? Ah, fucking camera. Yep, screen still works. That comes on alright. Okay, 14 volts. No power light though, as we had before. Michael C. At the time of failing, something has either pulled too much current from them or fed back something which has caused them to fail. So maybe I need to get my oscilloscope and be filming. Have like all the probes hooked up to all the different pins of the 074C, and be filming the oscilloscope to try to get data logging, to try and log some data to figure out exactly why they're dying. The pins that start leaking are different every time. That's the thing, it's not consistent. It's not consistently one chip or the other chip that's failing. It's one or the other, or both. And then it's the voltage is leaking from various different pins. Good night, Chris. Thanks for joining. One good fixer, perhaps the 074s are oscillating from a bad cap, but both amplifiers wouldn't just randomly have the same bad cap. That's the thing. Both these amps are doing the same thing, and the chances of both of them having the same random bad capacitor or resistor that just happens to be bad in the exact same way that's causing the exact same fault is too much of a coincidence. There's something else going on here. Maybe it's my test bench. Maybe it's my test bench. Maybe the TL074Cs don't like having the main ground connected to output ground. Maybe my signal generator. So maybe I should try and replace the 074Cs, and instead of running it on my signal generator, maybe I should either try nothing plugged into the RCAs at all and see if they die, or try like something isolated, like a mobile phone with a headphone jack, or an iPod, or something isolated that is a floating ground point reference to the main amplifier ground. Maybe I should try that. Both from the same customer? No, they're not both from the same customer. That's the thing. These came from like different places. So the common factor here is me. The common factor here between these two amplifiers is my workbench. So maybe it's something to do with this very sensitive amplifier not liking my signal generator. It'll be the first time that's ever happened, but it could be something like that. Alright guys, I am going to go to bed now. No, I can't speak Farsi, sorry buddy. What does bear vids mean? I've answered this many times on different videos. Maybe look back through them and check that out. It was just a stupid name that I had at 14 years old because I wasn't doing like 12 or 14 years old. I wasn't going to be doing audio videos. I was just putting bear vids onto YouTube. Bear is a UK slang for many, so I was doing many videos. That's why I'm bear vids. But yeah, okay. So I'm gonna order some new. I'm gonna order some better. I'm gonna order some better chips. I'm gonna order some dual op amps like the zero or quad op amps, whatever they are. 074s, but better models that are more resilient. And I'm gonna not use my frequency generator. We're gonna try something else and see if they die in that scenario. Gentlemen, it's been a pleasure. Thanks for sticking with me for what is now 3 and 3/4 hours, almost 4 hours. I will catch you tomorrow in another live stream, and we'll be looking at something different, not Hertz. Gentlemen, thank you very much. It's been a pleasure.